Hey, hello everybody. Welcome to SkyTour LiveStream for April 28th, 2020. It's a really cool night. I don't know how long we'll get. There's clouds coming toward us, and they'll probably be here sooner than later. But you know what? Tonight, I'd like to have us hunt for the asteroid that is the near-Earth asteroid that's heading our way, and we're going to try and find that as well. And Daryl has actually made an extraordinary effort to join us tonight. Hi, Daryl.
Hello, Mark. How are you?
I'm okay. You know, Daryl has, of course, as you know, he's been under the weather, and with all the stuff going on, we hope he hasn't got that weird virus that's going around the world right now. But he's hanging in there, so
I'm trying.
He's trying, yeah. So I want to welcome you, Daryl. I want to thank you for being a trooper, coming out and spending some time here with us tonight. I don't know how long you have, but you know what? You take it as you need it, and if you gotta run, you gotta run. So you just let me know, and that's fine.
Yeah, I will. And as I mentioned earlier, there are actually two very good Starlink train passes tonight. They're going to happen at about starting at 8:16 my time.
Okay.
And if we're still on, then I'm going to leave for just a few minutes. The first whole procession only lasts about 3 or 4 minutes.
Yeah.
So if I split, I will be right back.
Yeah, that's fair. And I got to tell you guys something too, and that is that the Starlink passes, I'm locating better charts so we can actually point the telescope at the area of the sky that they're going to pass through, and then like maybe see the train of satellites. Now you won't see, 3 or 4 all at once. You'll probably see one, and then a few seconds later or a minute later you'll see the next one. But if they're all in the same trajectory or path, then we'll be able to see them. And then so I'm trying to hunt that down for you as well. And in case you haven't noticed, this is Venus here. This is how it looks now. If you recall from a few weeks ago, it looked like it was almost a first quarter moon, almost like it was half of Venus. And now as it gets closer to us, it's getting larger in size in the sky, and we're seeing more of a crescent. And there will eventually be a very, very thin line all the way around the edge. And that'll be probably not visible from our observatory because it might be too close to the horizon for us by then. But we'll see. We're hoping to see that.
Yeah, an interesting thing happens now. It's Venus getting closer to us and therefore increasing in brightness innately. This is the old, what do you call it? The inverse square thing. If it's twice as close, it's 4 times as bright.
Yes.
Yet at the same time, its phase is reducing night by night. And at some point before inferior conjunction, when Venus will pass between us and the sun, it will hit the sweet spot where the crescent will still be getting skinnier, but the planet will be at its brightest. And after that point, the crescent will overtake the closeness of the planet, and therefore it'll start getting dimmer. Does that make sense?
Yeah, you're basically, if you add up all the bright areas and put them together, even though it's bigger, and even though it looks like a much bigger crescent, the overall lit area would be smaller than something like we see here.
Uh-huh.
And that's basically how it works. You just have to take all the lit areas and imagine adding them all together, and then this all seems to make a little more sense to you.
Yeah, sounds too much like calculus to me.
But that's funny.
Yeah, there'll be a happy place where, even though the crescent is getting skinnier night by night, the planet coming closer night by night will still rule. But at some point, the planet will continue getting closer, but by that time, the phase of the planet will be so skinny, such a skinny crescent, that it will dominate, and therefore you'll see the brightness of the planet start to drop.
Yeah, and that's true. But I think it's really interesting to watch Venus, moving, basically in the sky, essentially changing its phase right before our eyes over a period of several weeks. Not nearly as exciting as watching, say, an asteroid move across the stars in the course of a night, or a comet moving through the sky. But I can tell you that we're going to look at an asteroid tonight that's actually one that has been said to be a potential danger for us, but not anymore. It's called 1998 OR2, and it's a wonderful little asteroid. And I'm hoping that we'll get a chance to, see it against the stars before any clouds come in. I think that'd be kind of nice. Now, it's actually dim. It's a magnitude 10.95, almost magnitude 11. So what that means basically is that it's nothing that you could ever hope to see with your eye, and certainly not even with a pair of binoculars, regular binoculars. You definitely need a telescope for this. But it's something we're going to look for tonight and check it out. And if we take multiple exposures, you might even see the motion against the sky, against the background stars. In fact, that's how astronomers will actually pick out that there is something out there other than just stars. They'll take multiple pictures over time of the same area in the sky and then compare those frames to each other. Nowadays, it's done electronically, but in the old days, they actually had a system that was called a blink comparator. Remember those, Daryl?
Well, not personally, but yeah. I mean, blink comparator is what good old Clyde Tombaugh used to determine that Pluto was a putative planet.
That's right. In fact, I've told this story before. I sat with Clyde on a grassy knoll in Vermont, and we talked about when he found Pluto and the blink comparator, and he talked about how he used it. And when people tell a story of how they use a blink comparator, they inevitably close one eye. They're telling a story, because they're actually doing a comparison between two slides in their mind, and it's actually pretty cool. First, I just want to say hello to everybody. Hey, Marco. Hey, Tara. Hello to the Keen Tribe, and hi to Daisy and Zoe and Lane, who is now joining us again. Welcome, Lane. I hope you're having a good time. I hope you enjoyed last time. I'm really happy to see you here again. And we have Laura Newbert here, and of course you're here, Daryl. At least I think you're here. I'm here too, I think.
Trying to.
Right. We have Jarasco's here with us, and Kimmy is here. And my Daily Side joined us early on to say hello. My Daily Side was the first one here. Actually, an hour early. So I think that's pretty cool. And Headband Harvest is here with us. Hey, guys. How's it going? Nice to see you. If I missed anybody, write something in chat. Farva's here, of course. And Farva, thank you so much for the donation. That is outstanding. You're an amazing person, man. So I think it's pretty cool. So, I hope... Oh, and of course, Marianne. Don't give me that look, Marianne. I see it now. Okay. She is here as well. Marianne is essential for helping us to set up SkyTour LiveStream West. In fact, today, she was... coming at me at high speed to talk about the pier that has to be made, because she's going to orchestrate getting that made out there in Arizona. And then I'm making some pieces of it here with a gigantic 5,000 watt laser cutter that's going to cut plate steel into the shapes we need. No, it's not my laser cutter. I do have a laser cutter, but it's only 30 watt, not 5,000 watt.
Wow.
Yeah.
So did you borrow this 5,000 watt laser, or are you going somewhere else, or what?
It's at the top of my hill here in an industrial park that's tucked out in the woods.
Oh,
and
wow, cool.
It's a metal company called ENS Metals. They're a phenomenal place. They do metal fabrication of all kinds, and they do the most amazing work. I've seen their work over the years, and they do everything from Up Armor Humvees to delicate, wonderful wrought iron railings for homes, classic homes. They're just really, really good. And they do industrial stuff too.
Oh.
Yeah, and they make telescope piers.
I'm sorry.
No, it's okay. I said they make telescope piers too, for me.
Oh, I bet they do. I wish I had a 5,000 watt laser. I'd never leave the house.
It's true, man. It's true.
My job before I retired, part of it was I was an industrial mechanic, okay?
Yeah.
And my last 8 or 10 years there, taking care of 14 lasers was part of my job.
Wow.
And we had 6 100 watt YAG lasers, ND YAG lasers, and 8, 10 100-watt, up to 100-watt
Okay.
CO2 lasers,
Wow.
and they were used for engraving. But
Yeah.
I always thought, ever since I saw Goldfinger when I was a little kid, I wanted a laser.
No, Mr. Bond, I expect you to die.
Yeah, exactly. And well, I discovered the hard way the reality of being the guy that has to maintain 14 lasers wasn't as much fun as it sounds like.
Yeah.
I did get to do some cool stuff, and I saw the operator do some really cool stuff. Some people have a gift for it, and but taking care of lasers and keeping the optics clean and keeping the mirrors, the optics aligned, and all that stuff, it's not that much fun.
Yeah. Well, that's true. I mean, because the way a laser operates, for those that don't know, and Daryl, of course, knows this like the back of his hand. Lasers operate with a high power supply, and there's a gas tube, and it causes a reaction with the gas tube when the high electrical field is passed through the gas, and it begins moving in the tube, and there's a mirror at one end. It's a solid mirror, okay, to get as much, like 99.9% reflection off that mirror. And there's also a mirror at the other end of the tube, but that's only a half silver mirror, meaning that some of the light, a very, very tiny fraction, gets out of the tube with each bounce through the tube back and forth on these mirrors. And that small amount that comes out is the amount that actually does all the fancy laser cutting. Can you imagine if the full amount came out? Wow. I mean, that would be like a pulse laser can bring out a huge amount of laser a moment at a time, and it lets a lot of that out. But these lasers are really interesting. Mine is only 30 watts, and they cost, in the 90s, they cost a lot of money. But now you can get a laser where it's so cheap that you can actually throw away the tube, the laser tube that actually is the heart of the laser, when the tube dies, and just buy a replacement tube for like $300 to $400.
That is crazy.
It is crazy.
I had to replace the tubes on several of our CO2 lasers, which are gas lasers, and good grief, we were and with the core charge trade-in. Oh God, this one brand is called a Xenotech laser. We were paying about $5,000 a piece for those tubes.
Wow, that's pretty hefty.
And the ND Ag lasers, those are crystal lasers, and
yes,
the one neat thing about them was, well, it was reminiscent of the laser in Goldfinger. Instead of being a ruby laser, it was a neodymium doped. I'm having a brain lock here. ND Ag.
Arsenic and gallium.
Yttrium aluminum garnet.
Oh, is that what it is? Okay, yttrium aluminum garnet. Is it? Okay, yeah, I think you're right.
And it had a red crystal rod in it. It wasn't near as big as the one in Goldfinger, but it looked really cool.
Neat.
And it made the coolest screaming sound whenever you burn metal with it. The CO2 lasers were for doing wood and plastic and leather and stuff like that.
Right.
The YAG lasers were for engraving metal.
Yeah,
they just made this really cool, eerie, high-pitched screaming sound whenever they burn metal.
Wow. And so the metal, you think the metal had a personality, and you were hurting it. Stop it!
Yeah, you could say that.
Oh, yeah. I have a CO2 laser, of course, because it's I say of course because the YAG lasers are very powerful. I could tell a story how in college, one of the professors had a Yagi laser. We called them Yagis. A Yagi laser that didn't work and went to lunch. But while he went to lunch, the laser just sort of started to work again. The power supply, I guess, needed to cool off or cool down. And it started burning holes in the walls all around his office as it was reflecting. And he didn't know it until he came in, and there were holes in the walls.
Wow.
Yeah. Unfocused. I mean, it was a big like the size of your thumb in diameter, like so it was really, really big.
Wow.
Hey, Du, how you doing? Hey, Dagger, 24/7 live Arizona skies. What's up? Hey, and you know what? The other thing too is, I went down to Yale for some science thing I had to do, and I held a popsicle stick in front of a pulse laser, and it was just a little pop. It just went. And the popsicle stick had a half-inch perfect round hole in it. Just that quick. And you don't feel an impact, of course, because it's light. You feel a little vibration as the wood is being vaporized. But it just went, and you're like, whoa, whoa. And I kept that popsicle stick for many years. Hey, Tina, how you doing? Tina Pewterbauer's here. Thanks for coming out. And we're looking at Venus right now. This is actually the spectrum of Venus. I do have a spectrograph that's coming. We're a spectrometer, putting it on the telescope, and we're going to see details in the spectra of things that you just can't believe. So that's coming next. Okay, it hasn't been shipped yet. I'm waiting for it to be shipped anxiously. So that said, let me go back and get us to another mode. Let's try. We're going to go past the dark slot and go to the visual light slot, and it might not be focused, so we should probably focus that. As you can see, the sky is a little rough there, and that's because we are actually near the top of the roof of the house, sadly. But don't worry, we'll get it back. We'll be able to get it back. I have to. We'll see Venus, in other words, another night. No, I want to do a shorter exposure. Sorry, I'm going to do a shorter exposure to try and do this in visual, in a real light that we see, and this is my focusing size right here, just to do this. I want to focus, so that's out of focus, and now we come into focus. It is dim on purpose, guys. I'm doing that so I can focus. All right, that might be okay. All right, let's take a photo of that at a little longer, so it's a little brighter. And let's see if that works. That'll be at 50 ISO. That might be a little out of focus, but let's see. Yeah. And we're also going to look for the asteroid, like I said. That's we're just waiting for it to get darker because it's a little bit faint. A little bit faint. Oh, yeah. See, houses. Look at that, huh? It's like, it's like it's underwater. Yeah, we're trying to just, oh, sorry, you can't see that. Now you can. All right, yeah, this is what happens when you have a number of modes that you're trying to show. And I just want to try and get the focus straightened out here for visible light. This is where we are. Yeah. So, Daryl, what have you been up to? Sky watching wise and other.
Oh, I still, every clear evening, I go out and, watching Venus and the moon. The new moon came up a few days ago, and it's a little bit higher. It's a fair bit higher than Venus now.
Yeah.
And just admiring the sky, seeing Orion slipping away in the west.
Yes,
and,
it is.
In the morning sky, still watching Jupiter, Saturn, and Mars. Y'all might remember back 20th of March, Mars and Jupiter were very close together in conjunction in eastern Sagittarius.
Mm-hmm.
And then Mars had moved on and was closest to Saturn on March the 31st, I think.
Okay.
And now, a month later, Mars has raced so far ahead of both Jupiter and Saturn that it is way over in eastern Capricorn and about to head into Aquarius, I guess.
Mm-hmm.
And in the meantime, also, Jupiter is slowly catching up with Saturn.
Right.
And, it's just watching the dance of the planets night by night, morning and evening, and all that sort of thing. If you can get up before dawn, morning twilight, Scorpius is at its highest before sunrise, and you can see the whole figure of the scorpion and Antares and the scorpion's tail and Shala and Lysath, the stinger. And then Sagittarius, the teapot, is up high, and been admiring it also.
Nice. Yeah, we'll be seeing that again in July and August.
Mm-hmm. So, watching the world go by, I guess.
Yeah.
The worlds go by.
Exactly, the worlds. Some of them very big. So to answer questions from chat, the closest approach of the asteroid we're going to be viewing tonight, which is a 1998 OR2, will be on April 17th of 2079. Okay. And it will actually be about 1.79 million miles from us. It's like I said before, it's 10.95 magnitude right now, which is not really too bright, but we'll be able to see it. So as far as the asteroid itself, we're looking for this little tiny light. Now right now its current distance from us is 6.3 million miles, or I'm sorry, kilometers, and that's 0.042 astronomical units. So really, we're talking about something that is actually quite far away at the moment. It's not going to hurt us at all, as far as we can tell. And if we were to, let me just get you a value here so you can latch on to what I just told you. Doing something here for you, doing a calculation. Sorry, hold on. All right. So that value that I gave you before, 6.3 million kilometers.
That's not 0.42 astronomical unit.
0.042.
Okay, that's better.
No, I said 0.042.
Oh, I'm sorry.
No, it's okay.
Well,
that's fine.
I guess I need to clean my ears.
What'd you say?
Yeah, I was going to say, the number I've seen in conventional, standard units, they say it's 3.9 to 4 million miles away from us, or about 16 times farther away than the moon.
That's right. 6.3 million kilometers is 3.9 million miles. So,
hey, I use freedom units. So.
What units?
Freedom units.
Freedom units?
Yeah.
FUs?
Sure.
That's cool.
Everybody from a country that's put a man on the moon, hold up your hand.
Well, that's true.
Freedom units.
Okay.
By golly.
Hey there, space junkies. How you doing? I really like these names. And I want to say to Tina Peterboss, she said she was stargazing last night with her new binoculars. Tell me more. What did you see? What did you look for? I'd love to know what you saw.
And what are the binoculars?
Yeah, of course. That's where you got to know what the binoculars are, Tina. Don't just leave us hanging, hon. Come on. I want to know. Inquiring minds want to know, but astronomers want to know more. Yeah. So I'm going to check. I think it's getting dark enough to make use of this. I'm going to refresh. This is not what it looks like right now out there. This just happens to be the previous view that we saw. This was from several days ago. So I'm going to tell it to do some stuff here. That okay? We're all set. I should just be able to tell it to continue. Okay, we're playing that, and all right, we're gonna take a 40-second photo here of our sky, and we'll be back with that in a moment. Okay, so we'll have our all sky camera to look at too, which is actually the Arizona Desert STLS SkyTour LiveStream West all sky cam here, and we're moving that out west as well. I've got a lot of equipment here that has to go out. I can't believe it. And I gotta talk to Keith from P&K Space Imaging, and Keith thinks that if he's gonna be driving out that way, maybe he can transport some of this equipment. I think that would be an awesome idea if he could do it. So let's see, we get a picture yet? I think we did. Not yet, but we're gonna... Oh, I told it to take the picture. Why didn't it do it? Alright, well, it's taking it now. I noticed there was no water at all on this, so it's actually clean. I noticed outside it was clean. Okay, so depending on what this looks like, I can go out and move the dome. Yeah, there's the moon. Oh, look at that, huh? Beautiful starry sky tonight. Alright, so that looks really pretty. Yeah. What do you think, Daryl? Isn't that kind of a pretty sky?
Oops, it is.
With the moon, too, you know. I mean, here's the Big Dipper right here. You guys
absolutely.
can see it. There's the Big Dipper. And there's the handle of the Big Dipper, guys. And those two end stars point to the North Star, which is called Polaris. And here's the Little Dipper with its little ladle down there. And the comet is over here. And we are actually looking shortly. Well, right now we're looking at Venus, which is way over here right now. But it's actually, I think right now it's behind the house.
Yeah, I think so.
Yeah. And then in a little while, we're going to be looking right about here, which is, or just over here. This is where the asteroid is right now. And we're going to be heading over there shortly. Hey, Genghis.
Yeah. Hey, Genghis.
Yeah,
that's Leo where you were pointing.
Yes, that's right.
And that's Regulus and Alphard.
Yeah.
Let's see, the comet's in Hydra, right?
Yes, it is.
So then if that's Regulus and that next bright star to its right, I guess, would be Alphard and
then it's
Hydra.
right here.
And that's Hydra is the water snake, and Alphard
like
is the snake's heart.
Yeah.
And Hydra stretches all the way over to under Virgo.
Yeah, it goes all the way to here. And the nice thing is, where we're going to look is actually right about there. All right. Now, I know that looks low, and it is relatively low, but we're going to still be able to view it. And I'm going to go move the dome now so we can do that, okay? And I'll be right back, Daryl, unless you want to come along.
No, go ahead. I'll try to hold down the fort.
All right, I'll be right back.
I'm going to ask Tina a question or two. Tina, do you know what the aperture and magnification of your new binoculars are? You say they're the overwork astronomy binoculars. I bet they're the big ones. Are they like 105 or 105 aperture? If I had the ability to post a picture here, I'd have to send it to Mark, and I'm not sure I even have it on this computer. I built a set of giant astronomy binoculars years ago. They're two 6-inch f5 refractors slaved together. And I had to buy a big surveyor's tripod, anything that was stout enough to hold the mount and the refractors together, hold the whole thing, not counting the tripod. The mount and the tubes weighs like 45 pounds. And I had to buy a great big old surveyor's tripod to mount it on that would be enough to carry the weight. It gives really great views, but it's not really a very user-friendly scope. Not as user-friendly as I wish it was. But it's really cool and shows you some amazing things. I think it's hard to beat a good pair of binos for nice wide field looks at the sky. Everybody gets carried away with magnification. A lot of people think, hey, I'm getting a telescope, and if you see like Walmart telescopes and stuff, they scream like it's a 60 millimeter refractor, and they says it'll go to 600 power, which is a ridiculously high number. Usually you can get about, on a good telescope, you might get 50 to 60 power per inch of aperture. And a 60 millimeter telescope is, about 2 1/4 inches, if I remember right. So the most you could ever hope for useful magnification might be 120, 150 power, if even that. And that's predicated on it actually being a good telescope, which Walmart telescopes generally are not. But low power, wide field views, I think that's where it's at. And the binoculars just add a whole nother level to it. Gives you beautiful, rich, deep sky views. Oh, goodness. Hello, Jensen. Hello, Kimmy. Hello, Carolina. 12 by 60. Okay, Tina, the first number, 12, that will be the power, the magnification. 60 will be the aperture. And then the 100M at 1000M means that's the width of the field. You can see a field 100 meters across at 1000 meters distance. So that's a pretty wide field view. The 6-inch f5 binoculars I built, they will go from about 20 power up to 120 power. And I feel guilty because I design and build telescopes sometimes, and the sad part of that is, and this is not unusual for amateur telescope makers, you tend to lose interest after you build it. And I haven't had it out in a while, and I really feel guilty about that.
Talking about the Celestron?
Huh?
Talking about your Celestron?
Oh, no, not yet. Tina and I were talking about what binoculars she got, and I started talking about that 6-inch f5 pair. I think you've seen pictures of it.
You sent me some beautiful pictures, and I think we shared them with the folks, actually, on one of our streams where I had you and Amanda and me in the left side. There was a picture of you with those binoculars, I think.
Yeah.
Yeah.
One of those might have been, we all wound up at Bill's after I think my first KGRA show or something. And,
okay.
Amanda and I wound up holding down the fort almost all night. you stuck, and Bill left for some reason. I think he had to go lay down, and Amanda and I just sat there and talked for about 7 hours.
Wow. I remember that. Wow. Well, hey there, Terry Groff and Mothman Sam. Nice to see you guys. We've been, I just moved the telescope. Right now, I believe that we have, in this field, we have the asteroid that is approaching the Earth. It's certainly not going to be coming anywhere near us, not to worry. But it is going to be, coming close enough so that we'll get some, very cool views of it. But it's also one of these objects that's started life on the Sentry list. The Sentry list, of course, being the list that is kept of near-Earth objects, NEOs, that pose a potential, note the use of the word potential, danger. And in our case, we don't have to worry about this object because it's not going to pose any great danger to us, which is all good, That's all a good thing, don't you think?
Oh, yeah.
Oh, yeah. And then I'm just going through some parameters here. And we're going to do this. We're going to try this. I'm just setting up some parameters to see if I can adjust the auto guider. That's what I'm doing. So let's just do a 20-second photo. The moon is out, and we're doing a visible light shot. So this is actually going to be just a little bit bright. Actually, it is going to be bright. So I'm going to drop that from 16,000 down to 8,000. And it will probably still be a little too bright. So here we go. Hey, Dew. Good night, man. Thank you for coming out for a while. Sorry we started at 8:30 Eastern time, but we had to. We had to wait for it to get fully dark. Okay, let's see what we got. Okay, this is just a bunch of dots in the sky, right? However, we should be able to identify which one of these dots is actually the asteroid. And to do that It's certainly not the brightest one here. Let me just give you a better view. There we go. All right. It's certainly not this brightest one here, I don't believe. It's probably going to be one of these guys here. You know, something down in here. But we have to check. And the way we'll check is by taking another photo in a few minutes. And when we do that, we will actually then see if there's movement of anything. That'd be cool. Hey, Mothman. Yeah, I think I've done probably every season of that series. I don't know. You know what? I kind of like a voice of reason, you know? I mean, I certainly believe in extraterrestrial life. I mean, that's what my book's about, right? Finding it and using science as opposed to just I want to believe kind of a thing. I mean, that's all good too. But science is what's actually going to be the great convincer, right? So these folks come to me because I kind of have a reasonable approach to this stuff. You know, I don't disbelieve. I don't try to debunk. But I offer, you know, well, here's what this could have been. This is what this was, you know, once we know for sure. And I get to do some pretty cool things. I had to look at a Chinese photos from a satellite, defense satellite photos, and of a Chinese facility out in the South China Sea that the Chinese said was harmless, but I identified as being missile batteries. And I even identified which missile batteries they were based on the layout and wires that you could see, big cables that you could see running between them. I identified what launchers they were. So I don't think I'm welcome in communist China anytime soon. And guess what? I'm okay with that. You know, I thought it was pretty cool. And then we have Scrappy Dappy Doo. What's up? Are you in Tennessee? Ah, that's cool. I have friends in Knoxville. Memphis. Okay. So let me first see if I can bring us up with a kind of a finder chart to show us where this might actually be. I'm looking now. Oh, is that what I'm looking at? Is that where it is? Well, I'm closing in. I do think I'm closing in. Let me bring up the chart here. I don't know if this is gonna work to show you, but we're gonna see if it'll even show you. Hey, look at that! I lucked out. Okay, this is the finder chart for this particular asteroid, and we are looking. And I haven't done I'm not using a filtered shot, so I haven't looked at a deep sky view, but we will. And let me take this guy. Hang on. All right, let's move this over a little bit. Okay. So we're looking at it there, and we know that's the finder chart. We don't need that. All right, so we can also, if we wanted to, we can look at it this way. This is where it is in Hydra. Okay, Alphard is the star. What the heck was that? Oh, hello. I think I accidentally told it to go someplace it didn't want it to go. Sorry. Alphard here is the brightest star in the constellation Hydra, like Daryl told you. And then to its left is Lambda Hydra right here. That's what that symbol is, Greek symbol. And then we have Mu Hydra down here. The Greek letters signify a progression of lesser brightness. So alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pyro, sigma, tau, upsilon, phi, keep, psi, and omega. I mean, everybody knows the Greek alphabet, right? No? Oh, come on. So when we look at these stars, if we can find these stars, we can see that lambda and mu point almost directly to it. So we're going to try to find if we can see. I'm not sure about the scale. This is actually 50 by 30 degrees in size overall. So that's a lot. So we're looking at tiny little fraction of the sky over here. So we're going to have to take multiple shots in order to do it, in order to find it. But then the finder for the deep field is right here. And that's what we're going to be using to try and locate this thing. All right. Hello, Trish D. Welcome to SkyTour LiveStream. All right, so let's go see what we can find. I don't know if you can see it, Daryl. I can't yet. We're working on it.
I'm going back and forth between screens right now.
Oh, your mic is kind of low suddenly.
I'm sorry. Yeah. I'm going back and forth.
Okay.
I was saying hello to people in
Oh,
the
sure.
chat room. Yeah, you've got quite a close-up there compared to that finder chart you had.
Yeah, what I'm going to do is I'm going to change over to the secondary wide field, secondary narrowband. Okay, not narrowband 1, but narrowband 2. Okay, and now we're at narrowband 2. And narrowband 2 gives us a little bit more. You can see the 2 down here. This is the filter wheel down here. Narrowband 2 gives us a little bit more width in the slots of the spectrum that we're pulling in. So we'll take another shot here and take it for a little longer, so see if we can actually catch this. I think we can. So I'm going to up the ISO. Okay, we're going to go to 16,000 for 20 seconds. And I will do that. Hey, Donald Kunzer, how you doing? And Pradeep, how you doing?
I've mentioned before in other contexts that this thing must be moving, quickly. You said, I think, that its motion is going to be evident with comparing some time exposure, sort of like the blink comparator you mentioned earlier.
Right.
Two objects I can remember observing. I could actually see moving in the eyepiece of the telescope.
Yeah.
One was a comet. It was called Iras-Araki-Alcock.
I remember that comet.
And it went right by the pole star, if I remember correctly. And then Comet Hyakutake back in '96. Both of them, I just had them in a low power field of view eyepiece of the telescope, and you could watch it. You could literally see them moving across the sky.
Wow. Yeah. See, that's when they get close enough, folks. Objects out there in the universe can be seen to move. Obviously, let's hope they're not stars, because if you can see a star moving, we are in grave danger. The only one that we can tell is moving over a period of time is our sun that we can see on a daily basis. But in the nighttime sky, the only one we can see moving on a daily basis, or say a monthly basis, is Barnard's star, which is moving at a very fast rate. But I say fast rate, and that rate is really nothing that you could actually notice in less than a month's time. So it does take some it does take some getting used to when you look at these objects. So I think this is our first one taken with this guy, and thank you, Farva. Farva must be having fun with that telescope. I actually recommended a telescope for him to buy, and he went right out and bought it. And I think that he is. I think that he's pretty happy, or else he wouldn't be doing this like this. Thank you very much, man. But tell us if you're using the telescope. I'd like to know what you're doing with it, Farva. Oh, Mothman, I can tell you right now. Astronomers are not happy about the Starlinks, and as an astronomer, I just wait for them to pollute one of my photos. But you know what? The truth is, in the professional world of astronomy, it's not going to affect the research side, because many of the Starlink satellites are far below the level of, say, the Hubble Space Telescope, and won't pollute any shots from the Hubble nor the James Webb, of course, because that'll be far, far away. And so when you're talking about ground-based observing, well, you see, that's what ephemerides are for. That those are the ephemerises are the thing that are the calculation tables that show you where things are going to be and when. And if we know where they are, then we'll be able to, observe when they're not in that area of the sky. Hello, Leonard. Hey, Rocket Man. Hey, DK. DK said, you can be chatting. It's okay, DK. You're allowed to chat. No worries. Paul Atreides. That's a great name. I'll tell you why, because I'm a fan of Dune. I was actually just talking to my son about Dune the other night. Saying
a new version coming out.
Yes, yeah, exactly. And I was telling him that he should watch the old version. Okay, it's like a 3-hour movie, but man, the spice must flow. I thought it was pretty cool.
Oh, the Dino De Laurentiis version?
Yeah, way back, remember?
Oh, yeah. What's his face? Kyle MacLachlan. He played Paul Atreides in the movie.
Yeah, and then of course, Sting played Fade Rautha.
Yep.
Yeah, really cool.
Max von Sydow.
Yes.
Was in it.
John Picard. Patrick
Jean-Luc
Stewart.
Picard, yeah.
Patrick
Stewart. He was in it too.
That's right.
He was bald back then too.
He was. And I forget his name. Begin with a G. Okay, who in chat remembers the name of the Patrick Stewart character in the original Dune?
Oh, Gurney Halleck.
Okay. Yeah, you're right.
Wasn't it?
Yeah.
Yeah.
Yeah, Sting was actually Sting was Fade Rautha. He was the fighter for the wart guy there. Oh gosh.
Yeah. It was Sting's first movie role too.
Was it Baron Harkonnen? Baron Harkonnen, right? Yep. Yes. The spice must flow, Arizona skies. Yeah. Daniel Whitaker says Gunther, but I think it is right. It is Gurney. Yeah. All right. Let's take another picture, see if we can identify a change here at the same settings. Yes, we will do that.
Oh, that was Dino De Laurentiis. It was such a weird movie. It was kind of odd looking, but I've seen it a ton of times, and it's of the different versions that have already been out, is probably my favorite now.
Yeah.
It is a weird movie, though.
Oops, I had a little problem there with the guiding, so we're going to get rid of that. It is a strange movie, but, the fact is it was actually very well made for its time. I mean, you couldn't argue with the special effects of that time. They were actually stunning, for what they did. The thumpers, the way they brought the worms, that was just awesome.
Uh-huh.
And then, of course, you had the Navigator third stage. It was in that glass container.
It looked like a big aquarium. And
that's right.
That guy swimming in it.
That's right.
Swimming in
that thing is, yeah. Actually, I have a silicon rubber brain in my shop that I had to use I had to stick it inside of a lamp for some folks that was shaped like a human head, and then light it from inside, and then completely seal it in clear resin. Well, it looks like the Navigator third stage. And actually, if you look at it from the end, because it has a hole in it, and it has that little lip that sticks out, it's like, hey, look at the Navigator, third stage Navigator. Farva, once again, striking, man. Thank you. And When Worlds Collide was a great movie. Exactly. That's another fantastic movie. Gosh, it was really good. I really enjoyed that. Okay, let's see if we can see any kind of motion. It might be too soon. We might have to wait about 15 minutes. I'm looking. I'm doing sort of a blink comparator here. I'm going back and forth between the current shot and the previous shot.
Sean Young was in that version of Dune also.
That's right. Young.
Yep. She played, I guess she wound up marrying Paul. Yeah. I forget her name in the movie, but...
was she bald? in that movie?
Oh no, that was
Not a
well,
Bene
that was,
Gesserit. The Bene Gesserit witch, member?
yeah, yeah, she was bald.
Yeah. For you are the Quetzalcoatl Haderach.
Yep.
Yeah, that made the movie weird. Just trying to figure out, when he says Moadib and it shoots like, energy out and kills things. It's like, my name is a killing word. It's like, wow, don't say anything. Don't call my name. Yeah. I'm watching back and forth here, guys, just trying to see. We're going to have to let more time pass. I'm also going to consult charts as well again to see if I can identify where this would be. Actually, I know how to do this. I know a good way to do this, actually, to make it just right. See, because I'm trying to figure out where the telescope thinks its center is, and that's different from what we think the center is. So what I'm going to do is I am going to come back here. We're basically southeast of Regulus right now. And what I'm going to do is I am going to take us to Daniel Whitaker. Thanks, man. Thank you so much. Daniel Whitaker and Farva, you guys are like, you're keeping the lights on for us, man. Thank you.
Wowee.
Yeah. Okay, I'm gonna take us to this star here, and I think
I'm old, folks. I suffer from CRS. Only you can help. Please send money, lots of money. Only you can help with CRS.
only you can prevent forest fires.
Yeah.
All right, I'm moving the telescope to this star, and then I'm going to see where that star ends up in the field. And that's where we should look for the asteroid when we line up. Let me, first of all, get us to that star. Where is that star? Is that it way over there? Holy cow. If that's it, then the telescope's not very well aligned. But it is. I mean, I aligned it perfectly. That's better. That's more like it. Telescope was doing a high precision alignment. That's why. All right. Yeah, I thought it was going to be in the upper left. Okay, so let's let it settle out here. Let it settle out here. And once it settles out here, and we'll just take a 20-second photo. Why not? Because we're here. See, it's moving right now. It's moving around. Let's see if that's where it's going to stay. Okay, the telescope does... Here's how the telescope works. In order to get precision alignments when you have a telescope like this one, which has a higher power than the previous... Yeah, we're set now. Okay. The telescope will actually go to a star in the area. It has a database of all the stars in the sky that are brighter than like 11th magnitude. And it will then go to one of the stars near the object you want, align it, move it into the position that you want it in, and then it will say, okay, now that that's centered, I know exactly where the object you're seeking is located based on the coordinates you put in. The coordinates I put in are up here in the upper left, okay? And that's 10 hours, 34 minutes, 46 seconds, and minus 19 degrees, 20 minutes, 41 seconds. So now that we know that, then we can now tell it to go to that again, and we're going to look at this location in the view, and our asteroid is going to be in there. So let's go say go to, and you won't actually see the scope moving all that much. It's looking south right now, but you won't see it moving that much because we're actually trying to capture this object which is nearby. Okay, so this is the go-to star, I think, and there it is. Yeah, and that go-to star happens to be the same star that we've been using. We just went to by accident, okay? And now it's going to center it, and then boom, away it goes. And now it's going to go to the location of the asteroid, and you can see it and hear it moving there. Daniel, thanks, man. Thanks, Farva.
Mark, I was looking at your right ascension and declination displayed up at the top of the keypad.
Yep.
Which I guess is the ephemeris of the comet at the moment.
It is.
Since the comet is moving, and it looks like I see those numbers slowly
You mean
changing.
the asteroid?
I'm sorry?
These numbers up here?
I'm at the YouTube page again.
Okay, sorry.
Yes, those numbers up at the top of the keypad.
Okay.
Yeah, are those changing in real time to reflect the motion of the comet?
Yeah, are you able to read the screen? Because the right ascension and declination is here on the left. That's like latitude and longitude, guys. Okay, the right ascension are longitude lines, basically, and declination are latitude lines. But extended out into space, we call them right ascension and declination because astronomers love to confuse you. But really, that it does work, okay? But over on the right, you see the azimuth and altitude. So as the Earth rotates, okay, the azimuth and altitude of the selected object is going to change, okay? But we're not going to see too much of a change at all in the right ascension and declination because that is rigid, that stays. But the azimuth and the altitude here, that is to say the altitude above the horizon and the angle off of north will change because the Earth's rotating, and that's what's causing that. Okay, so that's what you're talking about, I believe, Daryl.
Well, but the comet itself is actually moving.
You mean the asteroid?
Excuse me, the asteroid is actually moving across the sky moment by moment.
That is correct. And
that does not reflect that?
No, we're not tracking the asteroid. We're tracking the stars. The asteroid will, if we did a long time exposure, we'll see a little tiny dash of the asteroid if it's moving fast enough. And I'm going to try that a little bit later. That's actually one of the things I want to try. Okay. But, as we see, this is actually a location here where the scope is. This is where our asteroid's supposed to be. Now, knowing how this centered things, we should see the asteroid over here. So I'll do another 20-second shot at 16,000 ISO. That's a pretty hefty ISO. And we're on wideband, the fairly larger narrowband filter. Okay, the wider narrowband filter, if that makes sense. Right now, we're not looking at the smallest slotted type filter, where it's actually looking at very tiny wavelengths. We're looking at fairly broad bands. All right, and so let's take a look at what we got. Well, what we got is a need to fix the get the guiding to work right. So I'm just going to delete this. Yeah, this is live astronomy. You take pictures and over time. So the asteroid technically should be over here. And what you'll find is from time to time this does happen. And usually that has to do with something called periodic error in the drive. And it seems that no matter how you tend to train the drive, sometimes the drive doesn't get the message. And sometimes it doesn't keep up with it sometimes. And that's what's happening here. Donald asked a good question. And we're going to have to get rid of this too. I don't know. Oh, wait a minute. Let me just check this out. This is... Okay. All right. I have a declination issue with that, so I'm going to fix that. All right. Donald asked an interesting question. He said, could we track the asteroid? Well, with this telescope, we can certainly track the asteroid. We can set our drive rate to be just what the asteroid is and then take a long exposure, and we'll see the asteroid as a dot and the stars as lines. We can do the same thing for comets. All right, but we have to know, which direction the comet is going and which direction the asteroid is going, and of course that requires a little extra work. And it's usually usually not something that we would do because it would take a lot of time to get it right. So I'm going to quickly just do something else here. I'm going to go in here. Wait, let's do this again here. Daryl, is the screen any clearer for you?
It was, and it got worse again. That's why I'm back over at the YouTube page.
Okay.
It's much crisper at YouTube.
Okay.
Let me check again.
All right.
You know the weirdest thing I've noticed before when the screen is fuzzy on me some nights like this? When like Amanda would come on board late, she would show up, and all of a sudden your screen is just crystal clear.
Interesting. Wow, that's pretty interesting.
Don't know why, but it does. But
hey.
yeah, I'm back over at the YouTube page right now because it's much crisper, and
okay.
I'm looking at the right ascension declination plus the azimuth and altitude you were talking about earlier.
Okay, cool.
And it was the azimuth and altitude that I was seeing change.
Well, you could be that famous writer Isaac Azimuth.
There you go.
James Dugan, how you doing? How's it going down in Australia?
I read a bunch of Asimov years ago.
Yeah.
He was another popularizer of science.
Yes, so.
And he wrote about everything under the sun. Plus, he was kind of full of himself. But can't deny, the guy was one smart cookie.
Yeah. Well, hearing that arrogance,
I guess.
Yeah, if you could say anybody earned arrogance, I don't. No one likes arrogant people. There's no reason for arrogance, Speaking of the satellites we were talking about, from right through the view, Now, that is a north-south moving satellite. Were the Starlinks going through Leo and Hydra? You sent me the darn finder chart too, and
tonight they're rising in the northwest. They are moving, at least the first batch. They're moving up about 51 degrees up or so high.
Okay.
And they're passing right between the Little Dipper and the Big Dipper.
Yeah.
And then they're dropping off in the southeast, and the early ones are going right to the east of a Virgo, and then the second batch is going to be going a little bit west of Virgo.
Okay. Well, we're gonna.
And they tend to move, more northwest, southeast, or southwest to northeast. Not in if you said that one looked like it was moving north to south or south to north.
Yeah, it looks like it's going from northeast to southeast, northwest to southeast.
Mm.
All right, I'm just looking here, guys. Again, we're looking in this area for an object that will be moving against the other objects. It's not going to be as evident as the comet, but it should be. We should be able to see it.
Gee, now a blink comparator sure would come in handy about now.
Yeah. Oh, wait a minute. Hang on. I found it. Okay, here it is. That's the guy right there. That's the asteroid. You know how I know?
How?
See that little tiny faint star? Well, let me zoom in. Okay, you see this little faint star right next to it? I don't know if you can see that. Let me zoom in even more. I'll zoom in like an astronomer. Okay, look it.
Okay, yes, I see that.
See what it's doing? Okay, compare that to this. Let me do a time exposure here. So I'm going to check to make sure that object looks like that's the object right there. and then the next view, compare it to the distance of the star. Look at now. See that? We found it. We found it, guys.
All right.
Right there. There is the asteroid, and it actually has made a trail on our exposure. Check it out. And the way you know, once again, we go back to the other shot, and I'm going to center this up for you guys because that's way off there. I just want you to look at the satellite trail, but look here, okay? Watch this. Okay. Look where this star is, and look where that object is right there, okay? And now look at the angle that they make to each other, and I haven't changed anything. Now look at this shot. Now look where it is. It was here in the previous shot. We found it, guys. We found an asteroid speeding through the sky. It is actually moving really fast. And now that I got that, what I'll do is I will leave it there. And now what I'm going to do is I am actually going to dare to take a 30-second photo. And we should see a little dash for that asteroid now. When it comes back, we shouldn't miss it. As long as the star is are still round. We should actually catch it. We might see a dash. We might see a dot. We'll see. Because this could actually also be an artifact of the tiny, tiny data on the sensor. But we'll see. Let's take a look. I'm really excited about it, I'll tell you that. But you can see it. There it is there. And here it's closer. So we actually caught it. We did what, Clyde Tombaugh did to find Pluto.
We'll have to start calling you Clyde.
Yeah, that's gonna work.
Yeah, it looks like it trailed there in that.
Yeah, this is the new one actually. This one right here, and you can see that it actually, it isn't. The stars are round and it's not. It's elongated. You see that?
Mm-hmm.
And compare that to the previous shot. Here it is here, and now we go to the latest shot, and there it is there. That's actually pretty cool, isn't it?
It is.
Yeah, I'm impressed with how that's worked out because you can see how it's moving by this star. It's going this way, in that direction, toward the east as expected, in this case. Very cool. That's neat. Hello, Laura. Hello there, huh? And Paul, Joey, Abaca, how are you? Or Abaca? Well, you know what? You know what it is? He says eagle eye. Well, okay. I know. This is the size of the field we're looking at, right? So somewhere in here is going to be our asteroid. And you just end up getting used to looking for small objects that are moving through the field, And that's what this is. It's a small object moving through the field. The earlier version of it is right there. And then as it moves to the latest place we looked at, there it is. So you can actually see it moving. This is asteroid 1998 OR2. And it's an asteroid that is, actually, as Daniel Whitaker says, it's moving very fast. He's absolutely right. It's moving a lot faster, apparently, than the comet Atlas was. And Atlas is still going, it's still out there. We can see Atlas too. But I thought tonight it would be great to just look at this because this is timely. This is the thing that is right now the most important find in astronomy right now is this little tiny dot of light. And yet you're witnessing basically essentially what would be called a discovery frame. So you see it down here now, say directly to the right of the star, and then in the latest shot it's up above. So it's actually moving more in a diagonal like this. Okay, so
up and to the left, up and to the left.
Yeah, that's what it appears to be.
I'm not surprised that you sound like you might have been surprised that at its rate of motion.
Well, it's a near Earth asteroid, so it's going to have a high rate of motion.
Exactly. Compared to the comet, their true motion and their true rate of motion in space, I don't know offhand, but I'd say the asteroid and the comet would be comparable, perhaps. But the asteroid being so much closer, well, we're going to see more movement in a given amount of time.
Absolutely. Absolutely. As long as it's moving what's called transverse to us enough,
Yes.
And what that means, folks, is as long as the line of its motion is more not toward us or away from us as much as side to side across our field of view.
Sure.
And that transverse motion, guys, is what I'm talking about. And we're seeing that here. With the comet, if the comet was coming right at us, for instance, let's say this was the comet right here. If that was a comet, we'd see it here on one night, and the next night we'd see it right there again. And it might not look any different. You know, it might have a slightly different cloudy coma if this was the comet. It's just a star. However, in this particular case, that would mean that it's coming right at us. Okay? So we need to see this transverse left to right motion to be able to really pick them out. And a blink comparator is good for that. We're actually doing a poor man's blink comparator here when we do something like this. All right. So here you see it's to the right of the object, and here you see it's above a little bit. And the telescope has not changed. We're still looking at the same object. You'll notice the star over here is at the same angle as it was back over here. Okay, there it is. Same angle. All right. So you go 1, 2, and across to 3. And now if you come over here and we do it again, we go 1, 2, and across, and it's gone. Oh, well, there it is. It's up above now. See, so we're actually seeing this. Hey, Goblin72. And Benjamin. Hey, Ben. How you doing? It is actually, where is it now from Earth? Okay, let me show you that. Actually, I can show you where it is now from Earth, now that we have it. Let me grab the right image here. Let me see. Let me just grab the right thing. As far as its distance from the Earth, it's about 6.3 million miles, I know, right now. And that's 0.042 astronomical units, or just about
Kilometers.
That's 6.3 million kilometers, correct? About 4 million miles. 3.9 million miles. So that's 0.042 astronomical units. And what's an astronomical unit? 93 million. So if you multiply 0.042, 147, which is the actual number, 0.042 times 93 million, you will get the distance in miles to the comet. Because you want to reduce the size of 93 million by about 400ths or so to get it down to 0.04. And you'll see that it's about 4 million miles, 3.9 million miles. And by the way, just so you know, it takes 8 minutes for the light to get here from the sun. And when we looked at Comet Atlas, the light took 8 minutes to get here because it was about an astronomical unit from us for much of the time we were looking at it. Well, this asteroid is so close that the light takes only 21 seconds to get here. Not even 30 seconds, So it's basically, it's just a very fast-moving object, So for those who are just looking now for the first time, here is the asteroid, and this is our view that we looked at. So you'll say, how the heck would you ever see it? Well, sorry guys, I'm an astronomer. We look for these kinds of things. And besides, I've got a whole bunch of people watching who want to see this, So I'm going to make sure I find it. I don't give up. You know me. I'm Mark, just one more object, D'Antonio. Right? And Kat Hobson, how you doing? Kat is a darling woman. She's the most enjoyable person to hang out with. And a real sweet lady. She actually has a paranormal radio show, I believe. And Kat, put the information in the chat for people so they can check you out, okay? Because you certainly deserve a mention, for sure. And if you notice, again, so here we are a little while ago, and I can tell you exactly when that was. If I just look at the timestamps on the information here, and I'll do it in a minute. Okay, that was this little guy right here in that frame we were looking at right here. Okay, that little guy was the asteroid passing by this star. But back then, it was actually just a little while ago, about 20 minutes ago, it was here. But now, when we look at it again, you'll notice that it's up here. So it went from here to here in about 20 minutes. All right. So really making a much faster movement across the sky than the comet. And as Daryl said, that's expected because it's closer than the comet. You know, the comet was an astronomical unit from us, 93 million miles. But over the course of about a half hour, we could see some movement. Here, after just a few minutes, we can actually see some very fast movement across the sky. And I'm going to zoom in a little bit more. And the nice thing is, when I take a photo and then come back, the same exact location is going to be enlarged automatically, which is great. DK, it won't hit us, no. You know, it won't. But there it is. And again, it's just under 4 million miles away. Let's go to our view here. And by the way, for those who have joined us who have not been to SkyTour LiveStream, let me just give you the little brief introduction to show you what's going on. When you look at the screen here, this is our main screen. Here's a star here that we have in the view. We have a very powerful camera on the telescope, so we're actually able to image really well. This over here, this part is the telescope control cluster. It consists of movement for the telescope. Then down here we have a filter wheel, which has different types of filters that we put in there. And these will allow us to look at these objects in different lights, different bands of the light, different wavelengths. This is down here, this window down here, this is Dome Ops. Hi, that's me here in the observatory. And I'm not in the observatory, I'm actually in my inside my home, actually. And I have the observatory is remotely operated on my property, but still not near the house. And over here we have the observatory camera. It's a pan and tilt camera. I can move and zoom in and do all kinds of things. And then this is the camera control cluster, and this is the live view. Okay, so we're going to take another shot. I'm actually going to I actually want to see some motion, so I'm going to go take a 1 minute shot right now at 16,000 ISO. We should see some type of movement, and we're going to go back here. As you can see, we do see some movement here. All right, it is dragging out just a little bit. Okay, here we actually we caught more motion. I think that what happens is the pixels on the sensor will sometimes average the data automatically, and this is something we'd see. Now this is where it was earlier than that, and right around the same time we took this picture. So we actually have several pictures we took. We had this one, we had that one, we had this one, and okay, we're still waiting on the 1 minute. All right, so we'll see where it is when it comes in here, if the guiding is still reasonable. And there it is. Okay, and let's see what the difference looks like. Must not have probably. Oh no, yeah, you can see there's a change. You can see the change there. It's not. Let's go to here. Okay.
Is the scope guiding on the asteroid now?
No.
The stars appear to be elongated, like they're trailing, and the asteroid is not.
Yeah, that's actually you're right, and that just means that I've got to take the shot again. The guiding wasn't perfect, which I can do. I'll do it again. Actually, we've been successful with the 30 seconds. I haven't tuned the scope for the longer exposures tonight, so I'll just do 30-second shots. And before, let's get rid of this guy. And get rid of this next guy. Okay. Alright, so now we'll do a 30-second shot. I just think that it's pretty cool to get this. Let me go back to the white light shot. What's funny is the white light shot doesn't even really show the asteroid. That's incredible. Okay, well, there's that.
I would think the white light would show it better. I mean, your filters are, picking on particular elements, and
Yes.
well,
However,
I think just a rock flying through space would probably, just look best in white light. It's purely albedo, brightness.
yeah, but we also have to look at one other thing that I think I didn't consider, and maybe you didn't consider. Let's go check it out. I'll show you. Show you what I mean. All right, if we go now and look at our view here, okay, and I bring up the view, you'll notice we're actually kind of near the horizon on this. And how near? Well, we're 26, 27 degrees above the horizon. So we're starting to get the air mass, it's called, in between us and the view. So using a filtered view is going to be better than trying to look at it in white light, because the white light is going to be catching all that air mass. We're getting rid of the air mass and the glow in the sky entirely with what we're doing.
I understand.
So I think perhaps it's going to be a little better. I just think this is so cool that we caught this. Look at that. Amazing stuff. It's really quite amazing. Oh, that was a JPEG. JPEGs. Let me show you what's happening. This takes and provides 2 photos. The camera takes 2 photos, okay? Well, it saves 2 versions. This is the raw file. Then it saves this file, which is the JPEG. Now, you'll notice that it looks fuzzier. However, when we pull out, you say, oh, that looks pretty, that looks nice. But it really isn't, an adequate view of what we're looking at. We really need to see all the detail, all right? And in this case, all the detail, if we use the raw file, that's when we actually see the asteroid. But because of the way that JPEG saves its files, things like the asteroid kind of get lost in the muddle. See that? So we don't want to use JPEGs at all, ever, to do astronomical processing, guys. You always want to use what are called the raw files. And the cameras can produce some files that are not JPEG files. What's a JPEG file? JPG is the format. It's an image format, and they're filled with potential errors, because the purpose of the JPEG file is to be a small file, not preserve the data that was in it. So if you have a background in our sky like we do, here's a background. See, it's sort of blue, and that's the filter causing that, and the moon. Okay. Well, this background that we see here, this background is meant. The JPEG file tries to make it all one color, and get and blend other colors. And so when you have small objects like this asteroid that we just were looking at right here, that little tiny dot right there, that asteroid is going to get lost when we take a JPEG file, because this is what the JPEG file looks like with the asteroid. Okay, it's not really red. That reddish color is a product of the compression algorithm that is blending pixels around it. All right, and here it doesn't do that, and we see the asteroid. This is the latest photo, by the way, we just took. Okay, you can see it now, and you'll see the asteroid consistently shows up as a little dash. That's because in the time it takes us to take the photo, the asteroid does move a little bit. And in terms of its brightness, the asteroid is almost what's called magnitude 11. All right, and magnitude 11 stars are too faint for you to see with your eye. You need a telescope to see them. And this star here is probably a magnitude 8 or 9, maybe a little brighter. But literally, this asteroid would not ever be visible to your eye without a telescope. And we're seeing it here. Well, thank you, Kat. That's a very nice compliment. Thank you. Hey, Axie, how you doing? I see Axie has joined us. I just want to say, I'm really pleased to see who's come out. We have 62 people watching right now. So hey, man, come on out. We got the asteroid. We caught it, man. We caught it. Okay, that's a current picture, and this is the previous picture. Notice the asteroid here, right? And these two stars don't go anywhere, right? And then we look at the next. Well, now look at it. It's there. You're actually seeing the movement of the universe, guys. And we did it with Comet Atlas Y4. We could see it moving through the sky. But this is a space rock. This is a space rock that we're seeing, and I think that's a really interesting thing to see, So if you have any questions about this, let me know. I'll be waiting a few minutes here as we go and let the asteroid move a little bit more, and then we'll take some more pictures of it.
Mark, excuse me for a moment.
Sure, go ahead, Daryl. Now, just to let you know, this asteroid is almost 4 million miles away, but guess what? You know how big it is in real life? You know how big that is? That thing out there that we can actually see? That is a 1.25 miles in diameter, and that's it. 1.25 miles. Yep. Isn't that crazy? Yeah, so 1.25 miles, and it's actually a asteroid that is it's well, I guess actually I think that the asteroid's diameter it's 1.28 miles is actually the actual value, and it's actually an orbiter, which is actually a near-Earth asteroid, so it's an NEO, near-Earth object. Okay, and it's about the size of Manhattan, and we're actually seeing this. We're seeing it here. I actually think that's really cool. I mean, it's just beautiful. So here it is earlier, and here it is a little bit earlier. And then you can see it's moving for sure, clearly moving. And the asteroid actually is leaving a small trail because of the fact that it's moving, and we're taking a time exposure here. I'm doing that on purpose. Oh, space junkies. There's no dummies here, and there's no bad questions. Let me tell you. I think that it's really cool to see. I'm glad you like it. I just like the fact that we're actually seeing an object that we can actually catch moving through space. It's fun. You think the stars are immutable. That is, they never change. You think that they never change. You think that the universe doesn't change for, in short periods of time. Yeah, here it is. It is one that has changed, Now, this particular asteroid is one that's of what's called the Amor group. And for those that deal in kilometers, because we have people from all over the world here, it's about 2 kilometers in diameter, just about 1.28 miles. And the asteroid was discovered back in 1998 by astronomers with what's called the NEAT program. NEAT as in Tom. That's the Near Earth Asteroid Telescope. And that's at an observatory in Hawaii known as Haleakala. And Haleakala Observatory is where this was discovered back in 98. So I think that's pretty cool, to see it. And so I had determined earlier today that since that asteroid was going to be an important whizzer for tonight, it was going to whiz through our sky, that I would actually want to get some photos of it. And I thought, hey, I'm going to bring you guys along because I have a feeling you'd like it. And so far, you seem to. I'm really happy with that, If it's not Comet Atlas, we're looking at the asteroid. Pretty cool, I want to thank the 65 of you watching right now, and I actually would like to mention to you that, if you're interested in reading more about asteroids and extraterrestrial life and exoplanets, I am an exoplanet astronomer. That's what I went to school for. Well, I went to school for astronomy, and then I focused on exoplanets after I got out. And I wrote a book called The Populated Universe, available on Amazon. That's a shameless plug, I guess, and I'm sorry. But The Populated Universe is about the quest for extraterrestrial life. And it's not a historical thing, but it talks about the Earth and how life formed here, and what we have to look for here so we understand how life could form there. It's a scientific justification for all of your beliefs out there that there's life in the universe besides us. It gives you a scientific backdrop that you can say. Now, when someone says, "Do you believe there's life elsewhere?" you can say, "Yes." And normally you might say, "Because I can't believe we're alone." That's the answer people typically give. Well, now you can say, "I can't believe we're alone, but guess what? Here's why." And then you can give scientific, valid reasons why we're not alone in your view, and which is, of course, my view as well. So I think that's pretty cool. Really cool. You can find it worldwide on Amazon. It's called The Populated Universe. It's not a small book, and I have to thank Tara, who's in the chat tonight, Tara D. She was my editor. She went through and edited that entire 325 pages for the 8x10 full color version. And she found all the typos that occurred that I didn't catch. It was like hundreds of errors, and that woman was very diligent, and I give her absolute total credit for making this book as polished as it finally turned out to be. So I thank Tara profusely. And to those that bought the book, if you're enjoying it, you can thank me, but also you have to thank Tara for her editing. She did a really, really nice job doing that. So there you go. And as far as the objects in our universe, our local universe, our solar system, there's a lot of new discoveries that have been made. And if you want to hear about the discoveries, then you might want to tune into SkyTour Radio. It's the radio show that we do. Daryl, who's with us tonight, is one of the co-hosts, as is Amanda Curran. And Amanda and Daryl and I will talk about new astronomical discoveries. It's a show all about astronomy and extraterrestrial life. Basically, it's kind of like The Populated Universe, but in talking form. And soon we're going to be doing the book basically in video form via kgraradio.com. In a sense, we're going to be doing our radio shows, but they're going to be like live TV shows. And we'll be able to, you'll actually see lots of on-screen stuff. Like when I show you things like, if I go, hey, look, this is the diameter of the, this is the diameter of this asteroid and so forth. I'll be able to show you all that data. And I'll be able to show you simulations and show you, we can throw things at Jupiter and watch them collide. We can actually watch things orbit. So we can do things live and dynamically. That's where we're going with SkyTour Radio, which is going to be kind of weird because it'll be more like SkyTour TV. And that's courtesy of kgraradio.com. So our show is 8 to 10 Sunday nights Eastern Time. All right, and it's 2 hours of astronomy and astronomy-related topics. And if you join the Discord chat and get into Discord, then you'll actually be able to ask us questions live during the show, and we'll answer them if we can get to them. The last show, I had so many questions, I actually couldn't get to all of them. So our show is becoming somewhat popular, which I'm happy for. That tells me that you guys and the people out there want to learn science. You want to know science. I think that's the coolest thing, So anyway, I'm not trying to kill time here before taking another shot, so I am going to take another shot anyway and see what it looks like.
Can I say?
Hey, Daryl. Welcome back.
Well, thank you. Well, first, am I going to have to get a webcam? And Second, I listened into just a little bit of Sunday night show. I wasn't there, of course.
Okay, a little louder.
But
Your mic is kind of low there, Daryl.
I'm sorry. Let me check my setting here. Oh, okay. I listened into a little bit of Sunday night show, and I don't think you need me anymore. I think Amanda has come so far that she was holding her own very well Sunday night. And I feel like a third wheel now.
I don't think SkyTour Radio would be the same without you, Daryl.
Oh.
And
Well,
that's and when it comes to SkyTour Radio, I'm the boss, and I don't think it'd be the same without you. Amanda's fantastic.
I want to raise it.
Hey, so do I.
Yeah.
Yeah.
I think my attendance needs to improve to get a raise anyway.
Oh my gosh! What? You kidding me? What? There's 2 shows out of all the shows you participated in where you were under the weather and couldn't attend. I wouldn't have wanted you to try if you weren't feeling well. No way, man.
Well, anyway, I think it's been more than 2, but carry on. Let's look at the asteroid.
Yeah, we are. We just took the latest picture right here. There's the asteroid right there. And to see it more clearly, you have to look at it as Clyde Tombaugh did when he was looking for Pluto. He looked at a previous shot, and he saw an object here in the sky next to a star. Obviously, this is way up close to us in the foreground, and that star is many, many light years away. So he saw that in the sky, and then he took another picture, and he saw that. That shows something moving through our solar system. What could that be? And it turned out, in his case, this was the last planet in our solar system, which I think is still a planet. It's called Pluto. Pluto has 5 moons of its own. It's very active. It has nitrogen ice on the surface, water ice, and it's constantly resurfacing parts of it. There's a plane on it called Sputnik Planum, and it's being resurfaced constantly. It's amazing, So I think Pluto is a planet. I really do. And this here is just an asteroid. But you have to admit, it's really interesting to look at an asteroid like this and then take another photo a little bit later, and then you see that. Whoa, it moved from there, just beside the star. It moved to up here above the star. I think that's pretty cool. I want to say hi to Carol. Carl, how are you? look, and hey, Daryl. Okay.
Yes, sir.
Daisy and Zoe say right to you, we need Daryl, and please don't go away. Yeah, okay. Enough with that. You're gonna have to go to your room, young man.
Soon enough, I will.
Yeah, I know. I'm
Which
worried.
reminds me, I am going to be departing for a few minutes here in about 4 or 5 minutes.
I'm gonna go check out the Starlink Pass.
Yeah, the sky's too bright. I'm afraid the first set's going to get washed out.
Well, I'd love to have you come back and tell us what you've seen.
Oh, I will.
Yeah.
I will. I mean, the whole thing, start to finish, is going to last like less than 4 minutes. So
Yeah.
there's a whole bunch of them, and they're strung real close together, which is one thing with the Starlinks I've yet to see. The really close ones.
Yeah.
They're going to be like 3 or 4 seconds apart in the sky.
Okay.
Just a great procession of them, but it's all, the first batch is going to be over in about from 8:16 my time to 8:19 something my time.
Yeah.
So less than 4 minutes.
All right. Well, when that happens, just let us know you're heading out for a bit, and we'll wait for you.
Very good.
All right. By the way, Tim F., I missed missed that you came in. Thanks. You came in a little earlier, and I didn't notice. I apologize. So we have the telescope trained on this area in the sky right up here, right here, and in that area of the sky, we are looking in the constellation of Hydra, okay, the water snake, and in that constellation, which if you looked at it as it's traditionally viewed. Okay, you'll notice how extensive this constellation is. It goes quite a distance through the sky, and it winds through other constellations as well. And Daryl pointed that out earlier, as a matter of fact. So, but when we check out Hydra, sometimes, and again, we have something hiding in Hydra right now. I mean, we have just now about 26 degrees above the horizon, which is fairly low. We have asteroid 1998 OR2. It's a fast-moving asteroid that you cannot see with your eye. You need a telescope to see it. But it's going to be only 4 million miles from the Earth, and it's called an NEO, a near-Earth object. I think that is... I actually think that that's pretty interesting, because we actually got to see it. Now, when we took the first picture of it, it really just... We didn't see... We saw this, okay, basically. Let me go back. Okay, and you have to take several photos in order to see it. And you're looking at these objects in here saying, okay, one of those is an asteroid. So what we had to do, and I'll just give you a better view, what we had to do was to take several photos and then look at them in succession and see what moved between the shots. Okay? So between these two shots, besides there being a satellite that went through the view, there was something else going on too. And, you couldn't see it unless you actually looked for it really closely. And that's what astronomy is all about, guys, is diligence and looking at things really, really carefully. So in looking
Mark,
at...
I'm sorry, excuse me. I'll be right back.
Yeah, okay. And Daryl's on his way to check out the Starlink passage over his location in Colorado. So looking at these objects, you look at every single dot and you take them in all at once, right? And then you look at a later one and say, something moved in this shot. What was it? Okay. And I looked back and forth a couple times and I found it. I found something that moved. It was right here. And then I zoomed in on it and I centered it up. I said, was that it? I went back to the beginning. Sure enough, look at that. It was here, and then it was there. Oops, sorry, that's a JPEG. Then it was here. So clearly, we had found this asteroid, and it was not very bright. It was a faint asteroid. It's only 1.28 miles across, or 2 kilometers basically. So it's actually a fairly small object, but we got to see it. And we're going to take more pictures of it tonight. And the nice thing is, like I said, when I identify where it is and I zoom into it, every picture I take will come in with the asteroid right at the same magnification and the same, with the same motion evident. Okay, so there we go. And we have to take some longer exposures too. Hey, put a mic. How you doing? Actually, it's like Putak Mic PC. Wow. Okay. I'll just call you Puta. Welcome, man. And then Ronald is here. Hey, Ronald, what's going on? And of course, that's ERRT Radio. You can tune into ERRT Radio on Mixlr. Yeah. Okay. So, with your eye, this is kind of what you see. It's really not very exciting, is it? No, sir, not at all. I'm going to try and take a few variant photos here. I'm going to drop down to 5,000 and take I'll try 30 seconds. Actually, I'll try a minute now because I haven't tried that since I made a change. We'll do a 5,000 at a minute. All right. And that's 5,000 ISO or sensitivity down from 16,000. So when we look at this, we're gonna have less of this grainy noise that we see here in our image. Okay, and the asteroid should stand out a little better. I didn't optimize the guiding rates tonight for perfect views for perfect guiding. I was very excited to show you guys the asteroid, so I didn't optimize. So I'm kind of letting it do what it does, and if it works, it works. If it doesn't, I may have to adjust things. But I do want you to see the asteroid and more of its motion. I just think that we've been having such a really good run of luck, with this asteroid. Look at that. It's right there, and then it's up there. Not bad. Now look at it. This latest shot, we see it went from here to here. And we see a little bit of a red haze, and I believe that's because either clouds are coming in, or which I'm not sure. Let's go take a look at our all sky view. Either clouds are coming in, and they might be. I have to just refresh this. I don't know why it stopped.
I'm back.
Hey, what'd you see?
Nothing.
Oh.
Sky's still too bright.
Okay. Well, welcome.
It's only 8:19, and
yeah,
it's not even astronomical twilight here yet.
Yeah.
But I may try again in half an hour. Second set happens 8:44 my time, I think.
Okay. Hey there, Huge. I'm in Connecticut right now, so I'm on the East Coast of the United States. And we're in June. I'll be going out to Arizona, to the desert, where we have another observatory going in at an elevation of about 2,000 feet. And we're going to have a second flat field. No, I didn't want a flat field. Sorry. Oh, okay, see, look. We're getting some high cirrus clouds. That's why I saw that red. Telltale sign. But you know what? It's okay. We're looking actually down below the constellation of Leo. And we're kind of actually right around here. So we might be able to catch some more before the night is done. Let's just check it out. Let's go back. The all-sky camera, guys, is really very, very important to being able to know whether your sky is staying in a pristine condition, or if you've got to, pack it in for the night. I will say this, though. Taking a picture here, this was the 1 minute shot, and actually the guiding looked really good. So I'm taking another one, and our asteroid. Oh, you didn't see it, Daryl. You did not.
What did I miss?
Yeah, you missed. Look at, here's the asteroid now, and here it was before, and here it was now.
Huh.
Pretty cool, huh?
Oh yeah, sure.
Anyway, that looks pretty interesting.
Are you getting lost in the clouds?
Yeah, I'm getting some clouds. If you notice, well, for anyone who notices, you can actually see. Yeah, I don't do flat fields, so I think I hit the wrong button on that thing. Yeah, so this is what our sky looks like right now. We're getting a few clouds. Yeah. Yucky. That's the dome.
Well, yeah, there's the Big Dipper, and the handle's pointing to Arcturus.
That's it, right there. It's zoop and down.
I guess that would be Spica over farther to the right from Arcturus.
Right there.
So it goes.
Yeah. Well, you know what? I think it was a very successful night, don't you?
Sure. I enjoyed it. I hope our audience did.
I think they did.
Well, it's so neat to see stuff like that. It's just, just another example of, the dynamic nature of the sky, really, if you look close enough.
That's right. The dynamic universe. Always in motion. Always in motion. Yep. Indeed, and it's just a really, really beautiful thing.
Yep. And that's more proof that winter's going away, and even the stars of spring now are falling off into the west.
That's right.
Be summer before you know it.
I know it, and I cannot wait. I'm gonna have such a good time with you guys, because once the observatory in Arizona is up and running, I can't tell you enough how beautiful the sky is there. But what I could do, I believe, is show you. I think that you would appreciate some of that. Let me go out here and look to show you what I'm looking at. If I can bring it up. And I have... Alright, 1 second here. Is it here? This must be it. I'm looking for all my imagery, folks, so I can show you. Yeah. Okay, so I'm going to show you some of the pictures that I took. One of the nicest ones, I just kind of set it up, is one that I'm bringing up now. Let's see. Okay, there we go. Now, okay, let me see if I can get this to come up. I'm going to go to a generic screen. Not that guy, but maybe... wait a minute. Hang on, I'm going to try and find it. It's not that one. Hold on, folks. I gotta show you some pictures here. All right, this is not the one I want to show you. So where's the one I want to show you? Ah, this is the one I want to show you. Let's see if it's active. Just a minute. Okay. Just a minute. Let's see if we have it. I think that might be it. You don't see it yet, though. Yeah, this is it. So I just have to show it to you. If it's going to show it all. Oh, it's not doing it. Okay, just hang on. I'm getting there. All right. Bear with me. I want you to see the stuff I'm doing here. All right, hold on. All right, I have another way of doing this. Okay, let's do it this way. Okay, we're gonna do this. No, we're gonna do this and say we're going to adjust. That isn't right. Alright, hold on a sec. Yeah, it's getting better. Alright, so this is an image that I took out there just as the night was approaching, and I was going to be taking photos of the night sky. The moon was relatively new, and that is to say, advancing in its phase, waxing. And this is the sunset view at SkyTour LiveStream West. I think that's really, really pretty. And now let's see if I can get us another photo to show you. Okay, and this was another one I took, and let's see, this was a photo taken of Cassiopeia. This is Cassiopeia right here. 1, 2, 3. 1, 2, 3, 4, 5. These stars right here. See? Let me see if I got it right here. It's a W of Cassiopeia, and this, you could see this northern Milky Way. This photo, if we look at the values in this photo was only 30 seconds long, you know, and that's it. Only 30 seconds long, and we already have a beautiful Milky Way here. So it was stunning. Let me grab some more. Oh yes, this is another location view, looking out into the distance past the observatory concrete pad. More moon, and more moon. Watching it. Now this is a photo. These are the raw pictures. There's no processing done on these yet. This is in Orion's belt. You can actually see Orion's belt here. Okay, you see one star here. This is Zeta Orionis. Alnitak. Okay, and then you have Alnilam, and you have Mintaka just out of the view there. Actually, it's in the view, but you just can't see it. Okay, and this is something called the Flame Nebula, and this is the Horsehead Nebula. How do I take these pictures? I put them on my Star Tracker Pro, which is actually a camera mount for your regular camera, and I had a telephoto, and I zoomed in, and I took these pictures. The blue color you can remove later, but that's actually a 30-second photograph. Isn't that incredible? See a lot of detail in there in 30 seconds. Here is a processed view of it. This is after processing. You see the entire belt of Orion there. So that's the view with my telephoto. I have to tell you, there's more stars here in the sky than you can even imagine. It was just absolutely stunning, you know.
See, pictures like that are why I like wide field views.
Yeah, it's stunning. Really, really pretty. And then I took another photo, and that was, let's see here. Let me see if I can get this up here. I'm going to go and just try and open it so I can show you directly instead of, having you wade through all the other images. Okay, so now here's another one that I took actually that night. This is the Orion Nebula with the Running Man Nebula above it. Again, just a short 30-second photo. But you notice there's dark nebula out here. You see more nebula out here than we even knew we've ever seen. And the Orion Nebula, when we look at the Orion Nebula, we see the Orion Nebula kind of ends here. Here you see it continue all the way around. You see it more for what it really is. Isn't that pretty? That's beautiful. And that's a process shot, so we can actually see what it really looks like. But I'll tell you, I've never really seen anything that looks so beautiful as our SkyTour LiveStream West location. It's just stunning. And another example is, let's see if this will work. Yeah. Here's the Pleiades. Again, a 30-second exposure. You can see all the nebulosity, the beautiful blue reflection nebula around the stars and the Pleiades in 30 seconds with a tiny diameter telephoto. Imagine when we put our giant light bucket out there. The photos are going to be unaccountably priceless. I mean, it's going to be just stunning. Okay. And so that's what we see here. This is the Pleiades. Now, let me pull up another one for you. I think that this one is by far. This actually tells us what the sky looks like. This is the Rosette Nebula. Okay, the Rosette Nebula in 30 seconds. When we take pictures of the Rosette Nebula, we don't see this many stars. The nebula's lost with all the stars around. But when we take this picture with our SkyTour LiveStream observatory, you're going to see detail that the size of the field is about like this. Okay, so it's much smaller, and we're going to see some really intricate detail here. I don't know about you, Daryl, but I'm looking forward to it, aren't you? Come on, you know. So.
Oops, sorry, I was muted.
I figured it's okay.
Well, yeah, for your sake, sure. I mean, golly, who knows? Maybe I'll make it down there someday.
You're welcome to come down there, actually.
Yeah, well, we'll see. What you should do is, I'll use a normal lens, like what a 50 millimeter would be on a SLR.
Yeah.
And grab the whole Orion Nebula and see how much of the other stuff, like the Rosette here, you can pull out in the image. I mean, you'll see the Rosette, you'll see Barnard's loop.
Yep.
You'll see the nebulosity around the Orion's head, the Mesa Nebula, the Orion Nebula, of course, and the Flame and the Rosette and everything else. And hey, you might even grab the Witch Head Nebula down there by Rigel.
That's right. We've actually done that before. We've tried that, haven't we? And here is a wider view, looking at just overall, looking at the lower half of Orion. Okay, which you can see here. And here is, of course, in this one view, we have the Running Man, we have the Orion Nebula, we have down here a curious little, which one is this? This is the, what's the name of the nebula? It's got a little black dark nebula sticking over, like the rubber stamp nebula, something like that, right?
Oh, I forget.
Yeah, it's down here. And we can see the Witch Head right here. Look at that. See it? It's a 30-second shot, and we can actually see this very, very faint nebula right there. And we see a piece of Barnard's loop right here. I don't know if you can see that. It's a reddish loop area here. So this is what we're in for. Now the haze you're seeing here, there's a haze, and it's actually in the center of the lens. Okay, right here. That was due to the fact that even in the desert, we do get humidity. And that's why we have to use, dew heaters and stuff to get rid of that in the telescopes. And I have one, of course, and I use it here as well. But I just thought that this is just beautiful, and of course, we couldn't do anything. We couldn't go a night without seeing a satellite coming through. And we had one right there. This is Orion's belt. We're not looking up at the top of Orion here, but just at the other parts. I just think it's really pretty. And now I think this is an overall view of Orion. And let me just pull us out of this. Yeah, this is an overall view, and it's kind of hard to see that. Let me move it over. Okay, I'll just zoom in and move you up and down. Okay, so here we go. So here is, So here is an overall view of Orion. Let me move this into position, minimize, bring it smaller a little bit to make it a little more easy to see, center it up. Yeah, so this here is the star Betelgeuse right there. This is Bellatrix in the upper right of Orion. Then as we move down into Orion, we actually can see the belt, of course, and then we see the Running Man Nebula and the Orion Nebula. Okay. Now, what's interesting is, again, satellites were running through and were rampant. These satellites are crazy. You just see so many of them. And we come up here, you can actually see, also right here, you can see the Barnard's Loop beginning. What's Barnard's Loop? It's a very, very large, diffuse, red cloud of glowing hydrogen gas. Okay. You can also see some dark nebula in here. And again, Orion is just filled with this stuff. And we're going to be able to see all of it and take pictures of it. So we have a lot to look forward to, guys, you know, a huge amount. Now, in addition to the satellite here, we actually caught another one here that was coming through. You see it coming in at that angle? These aren't meteors in this case. These are satellites. Meteors, when they flare out, they have this final burst, and then they stop rather abruptly, and these don't do that. They're more gradual. But I thought I would show these to you. Kind of like a little preview of SkyTour LiveStream West, you know. So that is what we have for our beautiful view in Arizona. And SkyTour LiveStream West is going to be brought online as soon as we get the telescope installed out there. And the building is getting built on June 24th. It's a one-day build. They're coming out, the crew's coming out, and they're going to build this building. Then we have the build roof separate, which is getting built. And it's going to be a metal roof because there are brush fires out in the desert sometimes, and we don't want to have any embers that could settle on a roof and burn through an observatory. So it'll be a metal roof. And then we're going to have as Marianne Robb said earlier in the chat, we're going to have a garage company come out and install effectively a horizontal garage door. But it isn't a garage door. It's going to be the actual roof, the peaked roof. And they're going to put it on rollers, and they're going to make it so that it rolls off the building. And that will become our amazing and wonderful observatory roof that'll roll off. And there's a secret that I haven't told you yet, and that is that we may not be alone in that building. It appears that I might have succeeded in bringing another group in with their telescope to actually take advantage of the Sonoran Desert skies with us. And that would be kind of cool, too, if they do that. Because that'll be twice. I'm
sorry. And the scorpions. Don't forget the scorpions.
Actually, scorpions are fun to hunt. When I was at Marianne's house, Marianne and Don, they have a backyard with some firewood in it. And Marianne knows this because we kind of sort of laugh about it. Marianne, so I said to her, I'm going to go hunting scorpions in your backyard. And she's like, oh, okay, yeah, you take a black light, an ultraviolet light, because they glow bright bluish purple from tens of feet away. You can't miss them. And I shined it at her wood pile when it got dark. I shined it in the wood pile. I found the scorpion almost immediately. And then I looked next to the house, and I saw one next to the house. And I took a stick and I kind of poked at it, and it ran off. And the very next day, she said a scorpion climbed out of her bathtub drain. And she said, that was a scorpion you scared into my house.
It always reminds me of the old Gary Larson Far Side cartoon. A guy's in a sleeping bag out in the desert.
Yeah.
And scorpion standing on his chest, and he's saying, pardon me, mister, the other guys asked me to come up here and ask you to quit rolling around so much.
And of course he had that look on his face like, ah!
Oh, yeah.
Yeah.
Mark, excuse me again, please. I'll be back in a few minutes.
Sure thing. Okay, our sky looks like we might have an opening here. Let's go check it out. I would actually like to show you a couple other things too, if we can, but we are getting some light clouds, and it's going to actually make it kind of tough. So I'm guessing that we're going to be kind of stuck. We saw the asteroid, which is great. Now our view is looking out of there. What else can we see from here? Wait a minute. Let's go look. Yeah. Well, we can try M68 actually. This says Melot 113. It's a globular cluster, and I'd like to check it out. But to look at it, we're going to have to be careful because I might have to move the dome again. But we'll see, won't we? Here we go. It's not like we have to be careful. It's not going to hurt anything. I don't make a dome so that it can be hitting stuff. And the telescopes, I gotta have it updating more. Okay, let me go back to this and tell me where it's going. And it's not telling me where it's going. I can't see where it's going. Alrighty. I probably have to remove the dome. Yes, sirree. Because that is certainly not. I'm gonna refresh that because it's. I don't think that's actually where it is. Okay, and I would be wrong. Apparently that is where it is, but the telescope... Oh, wait a sec. Let's see what I got going on here. Well, he could be in the right place, but I didn't see it to a high precision location of a local star, so that wasn't good. I'm going to bring that back up again in just a moment, and I'm doing it this way. Don't mind me. I am just doing my best to bring up this view again to try and make it obvious. Here we go. Alrighty. What is that doing? That's not right. Something is stuck. It's actually stuck on like time. See, I'm sliding it and it's weird. It's not doing what it's supposed to be doing. Alright, that's weird. Not a good thing. I don't know what it's doing. It's doing something odd and I don't like it. It's not right. So I will not be able to use that again. Odd as it is. Alright, well, anyway. What I'll do is I'm going to get out of that, get back to our other view, and we want M68, so that's easy enough because I can actually look at it a different way. I can find it by going to Objects and go through our measure list here and do it the long way. And let's make sure we can do it. And then I'll troubleshoot that other thing offline when you guys aren't around, because this is M68, right? There it is, M68. Come on, M68. Why is it saying it's suggesting it's not up, but I know it is. There we are. Okay, so I say okay. And the coordinates get updated up here, and I say go to. Now, it's going to do what I want it to do. There goes the telescope. So it's going to go to a bright star. It's going to find a bright star, and we'll see a bright star show up in here. I'm waiting. I think we're okay. There it is. That's our high precision locator star. And then once it finds that star, it's going to put it there, and there we go. And then it's going to take us down to the actual location that we want to see. Okay, here we are. All right. So now what we can do is we can actually look for this. There's a little star right here. We are back. We're ready to go. I give it a few seconds to capture, and then I think we should be able to go look. Let me make sure we can actually see what we want to see here. I don't know. Clouds are coming. Oh, I hate clouds. As do you. Okay. Well, tell you what. We're going to just try and take a photo anyway. It should be clear. I'm going to do 20 seconds at 20,000. All right, 25 seconds at 20,000. You back, Daryl? I think Daryl's on his way back. All right, so here we go. Yes, that provocative telescope sound. Carol. That's funny. Hey, Rock, how you doing? I don't think I said hi to you yet tonight. Thanks for joining us. Okay, let's pop out of this and see if we caught it.
I'm back.
Hey, what'd you see?
Oh, golly, it was pretty cool.
Really?
I saw maybe 20 of them following each other in a row across the sky.
Wow.
They might have been a little later than, just a few seconds later than Heavens Above predicted, but I picked up on them. They were coming up out of the northwest. They were going under Venus, heading up and to the southeast.
Okay.
They looked like they were coming right out of the moon, which was really cool. They were, on average, I'd guess maybe 3 degrees apart, 3 finger widths apart.
Okay.
And they appeared to be moving about a degree per second. They were headed down west of Spica in Virgo, toward Crater of the Cup, actually, I think. And it was pretty cool. I saw a good set of them last week, a week ago, last Friday, I think. And they also seem to be moving about a degree per second across the sky.
Okay.
And that night, a new one was popping up about every 10 seconds, so they were spaced about 10 degrees apart. And,
wow.
It looked cool. But, hey, there go my night skies, you know.
Yeah. Wow. That is very cool.
Yeah, but it was neat to see, and that's probably as good a set as I've seen so far.
Wow. Very nice.
Anyway, thank you for your patience.
Oh, of course. Not a worry. No reason to even suggest you need patience.
Well, I have very mixed feelings about the whole thing. You know, I've been into space and the sky my whole life, and astronomy and all that, and, you know, I just... it's a neat phenomenon to see. I've seen the shuttle many times. I saw the space station many times. Yep. You name it, I've probably seen it at one time or another. But yep. I don't enjoy like watching SpaceX launches the way I used to.
Yeah.
Ever since they started launching Starlinks, they've lost their luster for me somewhat.
Yeah.
And I do hate to think what the sky is going to turn into if there really does wind up being 12,000 of them up there. And
Yeah. It's not
this
gonna
is
be.
probably not the time or place.
It's not gonna be pretty.
I'll vent some other time.
That's all right. It's not gonna be pretty. We know that. You're
Yeah.
absolutely right. You're absolutely right. It's not gonna be pretty.
It was interesting to see, but I think going to get tired of them here pretty quick.
Yeah, no doubt.
Anyway,
we
carry
don't,
on.
We don't
Yeah.
want to
There
see.
I see on your. I'm back on the YouTube page because I can see it better.
Okay.
I may be a little behind you, but you can see where your pointer is at. It's over the tail of Hydra, looks like, and there's Corvus the Crow right above it.
That's
and,
right.
Then Crater the Cup just to the right of Corvus.
Yeah. We're actually using one of the Corvus stars as an alignment star to look for Messier 68.
Okay.
Yeah, which is actually a fairly. Yeah, it's got a magnitude of 7.3, and it's should be visible to us without any serious issue. It's actually kind of. We're gonna see. We're gonna see because we got the star. It should be right about here.
And this is Messier 68, you say?
Yes, it is.
Golly, I see M104 right directly above it.
Yes,
They're west of Spica.
Yeah, you do.
Have you looked at that yet?
No, I have not.
Oh, well, maybe after 68.
Yeah. Yep. Yep. The Sombrero Galaxy.
Uh-huh.
Okay, so let me take this image and see how it looks. We're going to do 25 seconds at 20,000. All right, and check it out. Now, I look at this image here, and I see that we have some clouds down here. If you see clouds all around the sky like this, it means that we're probably looking through some light clouds that aren't really showing up. But that's not. There it is. There's Messier 68, and as you see, we have a little red glow. And I think that red glow is due to the cloud that we're looking through right now, and not. Yeah, because we're looking kind of straight out the observatory. We're not looking. We're looking into some cloud near the horizon. That's what we're seeing right now. So that's what this red glow is you see on the screen. Okay. Which is no fun, but hey, it's kind of cool, that we can, line up and check out things. I was determined to. I had a problem with this trying to get it to work. It was failed. Flat field. Yeah, let me just go back into this for a second and bring up our view here. I must have hit the wrong button. I did. Okay, now this will not happen. Now when I hit this, we'll just see a photo. It's not going to actually tell me I have a flat field issue. I would like to adjust the sensitivity a little bit here. Let's do that. Let's see if this makes a difference. Just adjusting the sensitivity. That's pretty good. Okay, I'm just trying to help the clouds show up a little better. Okay. All right. So we had Messier 68 there, and now we can just go up above, as Daryl said, and we have this galaxy right here. This is Messier 104, and Messier 104, and just one more object, is a beautiful galaxy. It's called the Sombrero Galaxy for reasons that you will see. Okay, and the telescope is now moving to this star here, and it's moving to Algorab. Yeah, it's moving to Algorab, and There's Algarab. Oh, no, it wasn't actually. It's moving not to Algarab, it's moving to, is that Guiana? Interesting. No, Algarab. Okay. Right, and then it'll move to the Sombrero from there. So the way the scope works, as I said, is it finds a star near the object you want, and then it moves to that object. The sound lags behind the telescope. I'm sorry, behind the visual by just a little bit, just so you know. Okay, so we should see the Sombrero right around here. And we're going to do 25 seconds at 25,000. I don't know that I waited long enough for the telescope to actually acquire a guide star. See, it didn't even stop yet. So we might have a interesting looking image now coming up, as we'll see. So let's see where we're going now. Hey there, Lynch Hub. What's going on? Okay. Let's go see what we got. Oh. Yeah, see, I told you I was going to get some interesting results, didn't I? And I sure did. Wow. Okay, well, let's go back and do that again. I didn't wait for the telescope to finish. I just wanted to see what it would do. Let's do that again. Wait a minute. Why is it over there?
Yeah.
Oh, how silly. I think I may have, I might have accidentally changed its location by accident, guys. But let's find out for sure. It shouldn't be there. I'll let this exposure finish. Because honestly, all the images we see of the night sky are pretty, you know. Yeah, this is really pretty. Just looking at the sky, you know, and all those stars. I mean, I don't know. I just get excited about seeing the sky and the stars. Okay, let's go back and let's tell it to go to the Sombrero properly. I don't know why it didn't do that. So I told it to go, and now it's going to Algarab again. And it's going to center it up. It's doing something weird. It could be that there's a lip on the edge of the shutter of the dome, and that lip causes problems. Sometimes you can't actually see. The upper telescope that's guiding can't sometimes see. So by trying again, it might actually be able to find it. So we're gonna see now, because see, it did this thing again. It thinks it's there, but I don't think it is. And I can always try another method as well. All right, so I'll just take a discovery shot here. Just do 10 seconds at 20,000 to see what we got. And I think we're going to see the same images we saw earlier. So the telescope is going to require a little bit of massaging. Yeah. So what does that mean? I'm going to try a different way. Let's find out what the culprit is. We can go now to... We saw M68, but I actually found it by going here. So let me go here and let's see if the culprit is this telescope movement system, the Okay, let's look for, we're going to go to measure 104, say okay. All right, and now we have the parameters for M104, and now we'll say go to. Now let's go see what happens. Okay, we're pulling up a star, and that looks like it's Algarab. Looks like it's going to kind of go through the same thing so far. Yeah, it looks weird. It's doing something weird. It's got to be a visibility thing. It's having trouble seeing. So that's why with a roll-off roof, this will never happen, because it sees everything all the time. So we won't have this problem.
Sure would be nice if we had some grenades, huh, Mal?
Yep. Yep, and then it goes off and does that. It runs up to the Sombrero Galaxy, where it thinks the Sombrero is, but then it's really down here. So I'm going to try something to actually capture the Sombrero. I'm actually going to move. I'm going to move the telescope up here manually and see if it's being fooled. And if it's being fooled, it means if it's getting a partial lock and sort of knows where it is, then that's a good thing. So first things first, I'm going to increase the speed at which the telescope moves a little bit. Okay. And then I'm going to move the telescope.
Carol, that quote is from the movie Serenity, which is a follow-up to the TV show Firefly.
Which is a great movie. Great show, rather.
Yeah.
Yep. All right.
They were going to rob a bank, and Jane wanted to take some grenades, and Mal told Jane they didn't need any grenades for that job, and well, turned out they did, but they didn't have any. So.
Right.
And River Tam got, what was it? I got bugs in my teeth. Right, no, she said I swallowed a bug.
If you've never seen Firefly, that's actually a great show, guys. You gotta check it out.
It is. It is.
It's too bad it was canceled.
Yep, 14 episodes is all it had.
Yeah. And then they did some movies, which are actually pretty cool. Okay. I've actually moved the telescope manually now. I don't know. I'm going to check out and see whether this is going to give us our Sombrero. I'll just do a quick 10-second shot here. Meteor. Just kidding. It was just my cursor. All right, let's see what we get. Okay, the answer is no. So that's interesting.
Weird. Could you possibly pick Spica, and that would be close enough for the guide star or whatever to let you get to?
Well, again, there's. Let me show you what's going on in my view. I think, again, something that would never happen for the Arizona shot, place. Okay, telescope right now is angled up a little bit. Let's zoom in. Okay, it's angled up. And right here on the observatory is a lip on the dome shutter. And it's possible that the lip on the dome shutter is obscuring the view by the actual guide telescope, the one that is required to capture the object. There's 3 telescopes we're looking at on the telescope right here. We have one, the main barrel. We have a second one above it, which is the main guiding telescope too, but then above that we have another one, and that one is a small one. It's really in an odd position. I wish it would have been it could be moved, and it can't. So we need the clear view to use this, and I think that upper one is being blocked. So I'm gonna have to go and move the dome in order to see this. I'm not giving up on this, man. You know? I think that, let's try this though. If I say to go to Spica, let's see if I can actually get there. So Spica is the big blue. It's the big blue. Alpha Virginis. And let's see why let's see us. I want to see Spica. That's interesting. Here we go. And that is Spica.
When you see Virgo, folks, she's sort of lying on her left side, and she's holding an ear of wheat in her left hand down by her hip. And that is Spica. Spica means ear of wheat.
Yep.
Or ear of grain.
Yep. There you go. Okay, so Spica, it can see Spica. That's interesting. So what I'm going to do is I'm going to do this. I'm going to move Spica.
Hey, baby. Well, they show her standing up.
Oh, okay.
I always saw her lying on her side.
Well, that's probably when you saw her in the sky.
That reminds me of Xena Warrior Princess for some reason.
Really? I remember Xena. Remember that? That's the song for the beginning of the song for the show, I think. Actually, here's how you do this. You're watching live astronomy, guys. I'm going to do this. Okay, objects. I'm going to go to stars, and I'm going to look for Spica in the list. Okay, and when I look for Spica,
excuse me.
Okay, there's Spica, and I say okay. And now I say go to. So now the telescope pointing program has coordinates for Spica in it. Okay, and it is going to bring Spica hopefully back into our view. It's just off to the left. But I don't really care. I know where it is. I know where it's going to be. It's just off the left side. Here we go. And it's bringing it back in. And now what I'll do is I'm going to center it and sync it up. And that will align the telescope. All stuff I'm going to have to do from long distance anyway. Once the other observatory is up and running.
Once you're synced there...
Oh, look at that. Where'd it go? It should not have left. That's a weird thing.
It went that way.
Yeah, so I'm going to have to bring it back, and it's still going. So that tells me something very interesting.
If you can lock on to Spica.
That's my point. I can.
Yeah. Once you're there, can you just move the telescope? I forget how many degrees it is, but M104 is basically due west of Spica a few degrees.
Yeah, but see what I'll do is now I'm going to bring Spica back into the view, which should be, there it is. I'm going to center it up. Okay. And now I'm going to say sync. And now Spica is known now and it's synced. So that means that it now has new coordinates for where Spica is. And Spica's coordinates were off to the left, and that means that that's where M104 was, for whatever reason. So now, I think if I go to M104, and maybe even from in here, okay, I should be able to actually pick up M104 from here now. Because the telescope is what, the coordinates of the telescope are what are important. So now, if I say Control 1, go to this location. Go to the Sombrero Galaxy. It's going to take us to a star. And it's going to Aldebaran. What is that again? I'm not going to select it. And I don't... There it is. Okay, so here it is. Okay. That looks more like it. And then it should basically sync up and disappear and go right to here. And then we'll have the M104 in here. It's a question of knowing your equipment, right? So that's the last step, and then it should just zip away here in a moment. If it's going to work right. And there it goes. And now it should go up to M104. And it should end up staying at M104.
Looks like.
Well, give it a moment. Give it a moment. Right, that's fine. A little bit of little drift. Coming forward on the side stick a little. All right. Okay, so now I can actually tell the telescope program, the control program, that is where I want it to be. All right, so now with it there, it looks like it's ready. Let's take a photo now and see if we've got it. 10 seconds at 20,000 ISO. Yeah, we have different stars in the view here. All right. I think we're going to see M104 now. Probably right about here. That's my guess. And there it is. Okay, so we got it. All right, so this is M104, guys. Sorry it took so long. But I am Mark. One more object, please, D'Antonio. You can see that M104 has this really cool dark lane right across its middle, and then a bright part up here. The bottom part that's bright, and this nuclear bulge of the galaxy is somewhat eclipsed by this dark lane of dust. And this is only a 10-second photo, by the way. So why don't we do a real photo, shall we? Let's go on and go down to, say, 8,000. Okay. We'll do 10,000. But we're going to bring it up and check it out. Oh, Carol, that's very nice of you. Let's do 30 seconds. Okay. So for 10 seconds, you can see, guys, that the Sombrero Galaxy is a bright object. It's a fairly bright object. And now we're doing 30 seconds. So let's go here, and you'll actually see the difference when it comes in. And you'll see less of the noise as well. See? It's lower noise, and you can see more detail. Isn't that beautiful? Yep. So there's the Sombrero Galaxy, and I'm actually going to drop it down into the field a little more. And like I said, I just apparently had to realign it a little bit, which I did not expect to have to do. And by the way, this is a broader narrowband filter we're using. If we come back and we just go to white light, I'll have to refocus, but I want to show you. This is white light, and I'll just do I'll do 20 seconds here at 10,000 for the white light shot and show you what we're looking at. Again, we are higher in the sky than we were with the asteroid, but we can see that we're sitting at around 37 degrees above the horizon. Okay, and so here's our white light shot of the Sombrero Galaxy. That is the Sombrero, and it is as amazing as ever. It looks like a a beautiful object. The yellow color is sort of the right color. These are sort of the right colors that we see. And now what happens is we'll actually combine images like this with other images that we take with the filters. Okay, so if we come back now, we go to our filter number 2, our broader narrowband filter. Then we can now go up. I'm gonna actually do. I'm gonna actually go for a minute. What do you say to that? Okay. All right, 1 minute at 12,800. Okay, this is gonna give us a better view and show us more detail in the galaxy. I promise. Yeah.
Mark, huge EDBYT is asking about seeing the asteroid. Is it gone for the night?
It's fairly low now, yeah. So we have to kind of skip off it. It's Hydra is getting down too low in the weeds, and we won't be able to see it well enough, unfortunately.
Sorry, Huge.
Thank you for the request. We saw it earlier, but I will definitely be looking at it again. Okay, so we're doing 1 minute now on M104 using the more broad narrowband filter. Jeez. There it is. And now you can see some really nice delineated values here in this beautiful disk of M104. Look at that. M104 is a really interesting galaxy. It's been the subject of many a paper and study, and it's actually, if we look at it, it's only 29 million light years away. So it's actually a very kind of reasonably local, but it's not as local as Andromeda, which is 2 million light years away. Jeez. So we looked at M68, we looked at the Sombrero, M53. Well, hey, we're going to have M13, aren't we?
You have NGC 4565 right up above you, too.
Yeah, I know. I was trying to think about whether I want to go there as well. It's nice.
And
it's a beautiful...
You've got M87 up there, too.
That's right. M87, of course. We have lots of galaxies up here as we move into Virgo,
Uh-huh.
As well, and of course, all of them.
Oh, I don't know about all of them.
Oh, yes, you do. You know every single one of them. Yep.
Well, that's showing you signs of the Virgo supercluster there, those several red galaxies. And M87 is pretty much in the middle of the cluster. Yep. And everything else is congregating around M87.
Yep, like up here. This is a huge, and we're talking about this one that he's talking about. This is M87, the Virgo Galaxy. We can look at it. I'm not sure if where that's going to be at 59. We should be able to see that. Let me just back out a bit and see where we are. Yeah, I think we'll be okay. Let's check it out. We're going to go see if we can see M87. M87 figured prominently in past months because we were able to image the black hole in the center of M87. And it was really something. And here comes that star. They should move it over and lock it up, and then Okay. Okay. Gotta find that mute key, Daryl.
Sorry.
It's all right. So M87 is gonna be right near, and you see this bright star. We can look at where that star is. It's probably this guy right here. This is our field of view, by the way. That's the star we're probably looking at right there. So it's not exactly in the center. Shall we do a just a finder view, a 20-second shot, Daryl? See if we can find it.
You're the captain.
Oh, that's all right. You're the astronomer royale here. You know.
Oh.
Ah, you are. You do all the you do a lot of visual astronomy. You know, and I think that's really cool. You can't really have one without the other, I don't think. You need both. My expertise is one thing, but you also need someone who can also, you know, look up at the sky and say, "Oh, well, I know what that is. I know what that is." And I have some of that. I'm pretty good with it, but I'm not perfect. You know, not at all. Okay, we're just doing a 20-second shot here. Try and identify M87. So what do we got? There it is. It's over there. So it's not quite in the view. I'll have to bring it over. You know what? I'll tell you what I think happened. We've had a lot of rain here, and my pier is over 4 feet down into the ground. But I tend to think that the pier, because it's sitting on an area where there's a lot of fill, and I think that maybe the pier has moved a little bit.
Oh.
I think. That's my guess. All right, so I'm going to come down a little. You know, it's funny. I was talking to one of my, when I was getting my degree, one of the professors in the observatory was telling me about research he was doing down in Chile at Cerro Tololo. And that's one of the big observatories down in Chile where they do a lot of research, of course. And we'll do 20 seconds here again as just an identifier. And he said that during his photography, he was doing photos of these stars. He noticed the star swaying to the left and then to the right in a rhythmic left and right motion. And he couldn't tell what was wrong. He thought maybe something was wrong with the telescope at first. It turned out what he was seeing was the rhythmic motions of an earthquake as these S waves, these S waves, there's P waves and S waves, were moving through the mountainous terrain and impinging on the telescope building. And it was causing the whole building to undulate on the plate, tectonic plate. And he actually saw that.
Wow.
Yeah, pretty crazy. All right, what do we got here? This is M87 right here. And we've got a couple more galaxies out here, which are really pretty. I'm going to make a little change here for 1 second. I think I'm going to go and I'm changing some filters here. I got this. I have to bring back a little bit of the contrast. Okay, and we'll say that. Okay, and there we go. Okay, so we can actually see several galaxies in here, which is kind of cool. Messier 87 is 55 million light years away. It's a gigantic elliptical galaxy, but it's almost spherical in shape. And it has no spiral arms, just stars.
Is that the jet visible over at around 2 o'clock or 2:30?
Right here? Well, we'd have to take a longer shot. This is only a 20-second shot.
All right.
Should we take a 1-minute shot now that we have it placed?
If you like, sure.
Okay, I would like.
Because I suspect I see it in that image you have up now.
Yeah.
Just barely, but
Yeah, let's see if we can make it more than just barely. You're talking about this right here?
maybe not that far out, but
Okay.
a slight elongation there
Mm-hmm.
toward 2 o'clock.
Yeah, I see what you're talking about. Well, we're going to find out. There's a famous jet of material that's streaking out of this galaxy at very high speed. And it's, well, relatively well understood, but it's really a very interesting feature and phenomenon nonetheless. It's called a radio jet. And if you study it in radio waves, you'll see that there you can map it out and see that the radio waves are coming out fairly intensely. Now, the other thing about radio is just light. It's more light. Look at that right there. That's the jet right there, Daryl. See it?
Okay.
Isn't that what it is?
Yeah. Yes, I think you're right.
I think that's
Yep.
it.
Yep, that's it.
And so this jet of material coming out, again, we see it very brightly in the radio spectrum too. This is the visible spectrum, but we see it in the radio spectrum as well. And what's the radio spectrum? It's just very long wavelength material, and light that you can't see. It's electromagnetic radiation. Radio is light, which is kind of weird. People sometimes don't understand that radio waves are light that you can't see. I mean, infrared energy or heat is also light, but it's very long wavelength light. Longer wavelength, but radio is even longer than that. And that's what's really cool about radio waves. They do the weirdest things and show you the strangest things. And if you look at the spectrum of a galaxy in the radio spectrum, in the infrared spectrum, in the ultraviolet spectrum, in the gamma ray spectrum. Okay, gamma rays and ultraviolet are higher energy, gamma rays being much higher than ultraviolet. And in the infrared and radio spectrum, that's at the opposite end, longer wavelength. And the other stuff, the gamma and ultraviolet is shorter wavelength, very, very powerful. And when you look at those spectra, they tell you different things about the galaxy. There's an application that I recommend to each and every one of you. It may cost you a little money. It's not mine. I don't have any vested interest in it. But it's called Sky Guide. If you have an iPhone, it's a Sky Guide. And Sky Guide is a beautiful application. It even has background music, much like we play tonight. Okay, we have our music here, like we play. Okay, and Sky Guide plays its music while you're observing the sky within it. It's really, really a beautiful application, and you can actually get an addition to Sky Guide. All right, called why can't I think of it right now? Just had it right. I'm about to say it, and I couldn't remember it. I'll tell you in a second. I can't believe I can't think of it.
Senior moment.
It's a senior moment, I guess.
God, I have a lot of those anymore.
Yeah. It's called Supermassive. There's an edition called Supermassive, and Supermassive is really, really cool because it allows you to zoom in way more and go in so far it's crazy. And Sky Guide also allows you to look at the universe in the different wavelengths just by tapping on the screen. Then you get this little magnifying glass that comes up, which doesn't magnify the view, but just within the circle, which you can adjust the size of the circle, it'll show you what it looks like in the infrared. It'll show you what it looks like in the ultraviolet, in other wavelengths, in the hydrogen alpha, that is the light of the nebulae that are stellar nurseries. And so Sky Guide is really one of the go-to apps that I think you should really invest in. It's really pretty, and the music's beautiful too. Every time you select a star, it plays a little sound like ding, like a little musical note. It's really pretty. But anyway, I think tonight we had a successful night. I've got high altitude clouds now, so our views are being compromised by that. What looks clear here really isn't. There's a haze over this now of clouds. You can see them down here, through here. It's not like we're in a magical area where there's none. It goes across the sky. So the sky right now is pretty covered with light clouds, right? You're seeing through more of them as we look down toward the horizon. That's why you can actually see them. But they're actually going over here too, and you're looking through a thinner layer of them, thinner number of clouds looking straight up. So that's why it looks dark and starry here. But when you start looking down toward the horizon, you see more and more clouds until you actually can't even see beyond this. So we have clouds over the whole sky, but we're actually getting some really nice views anyway, so I think it's awesome. So I do want to say that we had a successful night hunting the asteroid, and I can't wait to go looking for it again. And I'm glad that you guys came out to check this out, man. And if you get a chance, if you haven't yet, go ahead and subscribe to SkyTour LiveStream. Hit the bell to get notified. I mean, you hear it all the time, but try it out. SkyTour LiveStream is fun to hang out. We have a good time together. Daryl joins us most of the time, and Amanda comes in sometimes. She didn't come in tonight. I don't think she got my message, but I did send it to her. But I do want to say hello to Hadley. I didn't say hi to you before, and I don't know who else came in. I said hi to Rock and Dave Schmidt. There you are. But you guys are just incredible, and I want to thank you again for joining me and Daryl tonight. And Daryl, hey, you hung in for the whole time. I'm proud of you, man.
Oh, thank you.
Yeah, I'm really glad that you could do it, because I know that you've been under the weather for most of the winter. And it's just been like crazy. It's like, oh man, give the guy a break, will you?
I wish.
Yeah.
Well, yeah, thank you for having me tonight, Mark. I had a good time.
Daryl, it's all right, man. You are a vital and integral part of SkyTour Radio on KGRA Radio, with us, with Amanda and I, and that's 8 to 10 on Sunday nights, guys. If you want to listen to an astronomy show that does dabble with the UFO and extraterrestrial question as well. So, but all from a scientific perspective, from what we know about those things from a scientific perspective. And SkyTour LiveStream happens on clear nights. Tonight was not supposed to be clear, so tonight is a magical night. We were able to do it, and I was very happy that we could actually provide a stream. I'm glad that it happened. So that said, I look forward to seeing you guys again. And remember, if you go out, don't forget, man, keep looking up, okay? Keep looking up. Even in the city, look for the brighter stars, and get Sky Guide for your iPhone if you have it. I don't know the equivalent name for the Android app, but on iPhones it's Sky Guide. 2 words. Anyway, you guys have a good night. And then I see Cindy Murphy. I see, hey, thanks for coming. And I want to say goodnight to Lane, who is with Daisy and Zoe Amethyst. Lane, I hope you had a good time tonight. Thank you so much for dropping by and hanging out with Daisy and Zoe. I'm glad that you have an interest in astronomy, and if you have any questions at all, any of you actually, feel free to contact me through KGRA. Our email address is skytourradio@kgraradio.com. So you guys have a good night, and we'll see you on the next clear night.
Night, everybody.